Good afternoon, and welcome to Bridging the Gap, Advancing America's Battery Manufacturing and Supply Chain. Before we start, please let me explain what you can expect at today's meeting. Your video and audio were automatically turned off when you joined. If you have difficulties related to technology, for example, if you can't hear a speaker or see the slide deck or visuals, we recommend you exit the webinar and re-enter. If you continue to have issues, you may also use the chat feature to send a message to AV support, who will then help you troubleshoot. The public chat is enabled to allow you to engage throughout the webinar. Just please make sure in the drop-down of chat to select everyone so that everyone can see your message. To ask questions throughout the event, please use the Q&A function, which is the icon labeled Q&A. You may upvote and comment on questions. If you submitted a video presentation and a question applies to your organization or your presentation, we encourage you to respond using the comment option located below each question. Finally, this event is being recorded and may be made available for viewing in the next few weeks. It is now my pleasure to introduce Venkat Srinivasan, Director of the Argonne Collaborative Center for Energy Storage and Science and Deputy Director of the Joint Center for Energy Storage Research at Argonne National Laboratory. Venkat, the floor is yours.
Thank you so much, Betony, and thank you all for joining the webinar. I know it's second day for many of you, and I see some new names, so it'll be the first day for some of you. So good morning and good afternoon, depending on where you are. So as Betony said, my name is Venkat Srinivasan. I'm a scientist at Argonne National Lab and the lead coordinator for the LiBridge Alliance. I will be the MC for this workshop. Sort of, you'll see me at various times during the day. Some of you heard this yesterday, but because I see some new people, I'm going to spend a couple of minutes telling you about what LiBridge is, and we'll sort of explore that a little bit more in the presentation following mine. So again, to remind you, LiBridge is a public-private partnership that is sponsored by the Department of Energy. We bring together the DOE National Lab System, that's the public side of the public-private partnership, and 3 US-based trade associations, NatBat, NYBEST, and New Energy Nexus. That's the private side of the partnership. You will hear more from my colleagues in the National Lab System throughout the day today. You heard some of them yesterday. And you will hear from the Trade Association representative, Jun Greenberger, in just a second. The goal of LiBridge is an important one. It's to create an innovation ecosystem to bridge the battery supply chain gap. And there's a reason to worry about the supply chain gap in the United States. And that's because we are at an amazing time in batteries where we have to worry about the supply chain that we have to fill. The market for batteries in the US is booming. And in the next 10 years, we're going to be talking about terawatt hours of energy manufacturing capacity per year for batteries. It was only a few years ago when gigawatt hour sounded like a big number. Now we're talking terawatt hour. So it's an historic time and an amazing opportunity that you should take advantage of, and a unique moment that I think can change the trajectory of how we think about this technology and the US in the future. But to capture the moment, we have to build a secure supply chain. That's extremely important. And let's be clear, there's a worldwide race to capture the battery market. The electrification is something that is here to stay. It's all across the world. And for the US, this means that we have to start thinking deeply about how we're going to lead this industry and capture the market by building the supply chain out. It's critical for us from a US competitiveness perspective. But we have to be careful about how we do this, because the growth has to be sustainable, it has to be environmentally benign, and it has to be equitable. And we need to have a holistic view on all the different battery markets that are out there. Electric vehicles for sure, grid storage, but also things like batteries for defense, where there could become a problem if you're not careful about how we grow this particular technology. In LiBridge, we want to have that holistic perspective, work closely between the public sector and the private sector, and establish a secure domestic battery supply chain. Over the next year, LiBridge will hold a series of workshops. You'll hear more about that in just a second, where we want to bring together people across the ecosystem, understand the challenges, and see how best to achieve this vision. This workshop is the first of that series. Our focus here will be on the bipartisan infrastructure bill, or the BIL, that is expected to hit the streets very soon. In this workshop, we want to hear from all of you, right? So there's a chat window, there's a Q&A function. Please tell us more about the exciting new technologies you're pursuing and the challenges you face in producing them domestically. We have a series of presentations that are going to talk about this, but we want to hear from the rest of you as to what you're sort of struggling with also. This can include technology challenges, but also financial issues, things like workforce needs, permitting challenges, and ultimately how we're going to engage the local community in ensuring that we're kind of making this successful. This information that you provide is going to be valuable and extremely important for decision makers as they start crafting plans for what to do as we go in the future. In yesterday's workshop, which was extremely interactive and it was a lot of fun, we were just talking about it before the event started, we were talking about the upstream part of the supply chain related to battery materials processing. Today, we want to focus on the midstream and downstream part of the supply chain related to the battery manufacturing and recycling part of the agenda. Let me quickly walk you through our plans for today. Following me, we'll hear from Jim Greenberger, who will tell you a bit more about LiveBridge and the activities that are planned on the private side of the public-private partnership. His talk will be complementary to the comments yesterday from my lab director, Paul Kearns. Paul spoke to us about the role of the national labs and the role we're playing in US competitiveness. Jim will tell you a little bit more about the private sector and the thoughts we have going forward when it comes to LiveBridge. Paul also told you yesterday about an interesting announcement, an important one, where LiveBridge will be collaborating with the European Battery Association to explore topics of mutual interest, where we want to learn from each other and understand how we can build these strengths as we go to the future. We will then hear from Dave Howell on the infrastructure bill and the plans related to that. Dave, as many of you know, has been engaged deeply in this topic for the last 20 years. We will then move to a session where we'll be hearing from the industrial perspective. These will take the form of pre-recorded presentations. Thank you all for giving us the presentations. And they'll be moderated by my colleagues from the different DOE national labs. We have approximately 69 presentations today. Actually, we have exactly 69 presentations today. So lots of interest and excitement around this topic. It's going to be a long day, but it's going to be well worth it just because of the importance of this topic. And finally, after we finish those presentations, we'll talk a little bit about permitting challenges, workforce needs, and the role of engaging local communities and ensuring environmental justice so that this is front and center during this growth period. I think we heard yesterday the importance of thinking about these aspects, especially thinking hard about how we're going to transition from an internal combustion economy to one that is a battery-powered economy, the changes that are going to happen, and how we ensure that everybody sort of benefits from the change. That will be the focus of that particular session. We have a couple of interesting and excellent presentations from the DOE leadership, followed by some discussions we'll have with the different national lab representatives here. We had a really wonderful interactive session yesterday. We're using a polling software. We'll try to do a little bit of that today. Again, this is going to be a long day of presentations, so we'll try to intersperse that with a little bit of these polling so that we can sort of break things up and get some input from all of you. But we want to hear from you. So use the chat window, use the Q&A, and tell us more about the kinds of things that you're worried about when you think about production of batteries across the supply chain in the United States. With that, let's get the program started. It is my absolute pleasure to introduce somebody that needs no introduction, Jim Greenberger. Jim, as many of you know, has been active in this area for a long time. He's the executive director of NatBat International. Jim co-founded NatBat in 2007. I knew that. What I did not know was he created NatBat at the suggestion of Senator Barack Obama. So it's Senator because it's 2007. And apparently Barack Obama wanted Jim to think hard about how we're going to ensure that all the electric cars that we're going to be making are made by American companies and by American workers. Jim is actually an attorney in training, which I think many of us know, but we've tried to convert him into a battery person. Since founding NatBat, he's become very deeply involved in the battery industry and served on many boards and as an advisor to the Department of Energy Battery 500 Consortium. Under Jim's leadership, NatBat has grown tremendously to have 200 companies, big companies, but also startups. He's been a great partner as we've been thinking about strategizing on how to even launch a public-private partnership, ultimately launching LiveBridge. With that, Jim, take it away.
Thank you very much, Venkat, for that kind introduction. Good morning and good afternoon to those of you around the world who are joining this program today. And thank you to the U.S. Department of Energy and the Federal Consortium for Advanced Batteries for giving me the opportunity to speak with you today. The purpose of my talk is to introduce you to the LiveBridge Initiative. The LiveBridge Initiative is a public-private effort to develop a strategy for the United States to build a robust and sustainable lithium-ion battery industry and supply chain in North America. NatBat International, which I lead together with our partner convening organizations, New York BEST and New Energy Nexus, have been asked by the Department of Energy and Argonne National Laboratory to help facilitate private industry's input into this important project. The convening organizations have in turn hired the Boston Consulting Group, one of the top management consulting firms in the world, to manage the project and coordinate industry's input. It's important to note that LiveBridge is a strategic initiative, not a funding mechanism. LiveBridge will not disperse any money and will not make recommendations to the Department of Energy as to which companies to fund. The goal of LiveBridge is to reach out to you in industry, you who are the experts in lithium battery technology and in running successful businesses. The US government wants your advice as to how the United States can establish a secure supply chain and maximize job and value creation in the lithium battery industry over time. LiveBridge's job is to collect and transmit that advice to government. Before I get into the details of LiveBridge, I want to talk for a minute about lithium-ion technology and why it is so important. As we meet here today, the economy of the world is in a state of energy transition. The transition is from an economy that has for the past 200 years relied on heat-based fuels to an economy that will rely on electric energy. There are good economic and technological reasons why this transaction is taking place. Electricity is a far more efficient and flexible form of energy than heat. It is also cleaner and can, of course, be generated on a carbon-free basis. The importance of the move to electric energy to the fight against climate change cannot be overemphasized. The technological transition from heat-based fuels to electricity may well be what saves humanity from the worst ravages of 200 years of unlimited carbon emissions. That is not, of course, without precedent. Human-created technology has a history of remediating human-caused environmental pollution. It's instructive to remember that 125 years ago, the big environmental concern was that the streets of Manhattan would soon be covered in 6 feet of horse manure. But an obvious technological change caused that not to happen. So there's an important lesson here for all of us in 2022. Let's embrace the change to clean electric energy and get all the horse manure out of the air. It would be great if I could credit battery makers and electric vehicle makers for this energy transition. But the real story behind the transition has more to do with the semiconductor than it does with climate change. Computers just don't run well on gasoline. The move to electric power is inevitable and irresistible. Properly understood, the electrification of vehicle drivetrains is not a revolution, but an evolution. The electrification of vehicles has been going on for decades. It started with power windows, then power seats and seat heaters, then safety systems and navigation systems. Electrifying the drivetrain is simply the next evolutionary step. Electricity is the energy of the future. Batteries will play a critical role in the new electricity economy. Batteries are the primary means by which electric energy can be provided to any point in space without the need for a physical connection to a fixed electricity grid. Accordingly, battery technology will be critical to all the new mobile devices, systems, and products that society will create and electricity will enable in the new electricity age. The advantage of lithium-based batteries, of course, is that they are based on lithium, the fourth largest element in the universe. For the foreseeable futures, lithium batteries will be the lightest and most efficient way to get electricity to any mobile device or system. Accordingly, lithium-based batteries will be critical to the operation and also likely to the development of those new devices, systems, and products. That is why lithium batteries are and will be the cornerstone of the new electricity economy. Lithium battery technology was invented in the United States. It is not news to anyone, however, that American companies have fallen far behind in the competition to manufacture that technology. According to the FCAB's National Blueprint for Lithium Batteries, the United States, which is the largest national economy and second largest automobile market in the world, produces only 8% of the lithium battery cells, 10% of the anode materials, 6% of the separators, 2% of the electrolytes, and a negligible amount of the cathode materials used in lithium batteries. The real danger of falling behind in the manufacture of lithium batteries is that it implies a parallel falling behind in lithium battery technology know-how. Building battery gigafactories is easy. All you have to do is spend money. But building the know-how needed to operate those factories to produce the safest and most efficient battery technology possible is a much greater challenge. We pride ourselves in the United States on being the most innovative nation in the world, and there is solid truth in that boast. We have and continue to produce some of the best scientists in the world. But there is truth too in the old adage that 90% of all innovation takes place on the factory floor. Lithium battery technology is a good example of that adage. Over the past decade, we've seen a 90% drop in the price of lithium-ion batteries. This price drop has been driven not by scientific breakthroughs, but by hundreds of small tweaks and efficiency improvements in the way that lithium-ion battery cells and packs are made. Manufacturing experience is an essential component of innovation. World-leading innovation in lithium battery technology, the very cornerstone of the new electricity economy, is not realistically possible in the United States if we're only making 8% of the world's lithium batteries. The United States is not the only country to recognize the profound implications of the energy transition and the opportunities that transition to reshuffle the world economic order. China has jumped into the electrification economy with both feet. More recently, so has Europe. A worldwide battle is shaping up for technology leadership and the best jobs of the 21st century. The United States has not yet lost that battle, but we need to start fighting it soon and in earnest. The competitive battle among manufacturers of lithium battery technology will influence not just where lithium batteries and their components are made, but also where the devices, systems, and products powered by those batteries are developed and made. Those devices, systems, and products will form the core of the 21st century economy. As in any economic competition, there will be winners and there will be losers. The goal of LiveBridge is to give American companies and American workers their best possible chance to be winners in the new electricity economy. LiveBridge will be about figuring out how to win in that worldwide competition. We'll seek to answer some big and very complicated questions, such as what does winning actually look like? Where do we play? How to win? Good answers to those questions will need to take careful account of the strengths, but also the weaknesses of the American economy, political structure, and legal system. Determining where not to play may turn out to be just as important as determining where to play. The mechanism for answering those questions within LiveBridge will involve 6 committees, each focused on a different aspect of the supply chain challenge. The first committee will focus on technology, innovation, and transparency. The second will focus on demand, supply, and availability. The third on economic competitiveness and differentiation. The fourth on manufacturing and infrastructure. The fifth on workforce and communities. And the sixth on go-forward operating model. Each committee will consist of 6 to 8 members drawn from companies selected by the Boston Consulting Group, with the goal of including on each committee companies representing a cross-section of the entire lithium battery supply chain. The individual committees, after studying their designated areas of focus, will meet in a series of 4 forums running from April to July of this year to discuss and try to reach agreement on how to answer the big and complicated questions I mentioned before. From time to time during their deliberations, the committees will be reaching out to broader industry for input and comment. The listening program you are attending today is an example of the type of outreach that LiveBridge committees will be doing to make sure that LiveBridge obtains the best possible input from industry. The nominal culmination of the LiveBridge project will be a white paper prepared by the Boston Consulting Group, summarizing the recommendations of industry as to how to optimize the US lithium battery supply chain. But the real culmination will be a go-forward plan, putting in place mechanisms to ensure that whatever recommendations LiveBridge makes are taken seriously by government and attract sustainable bipartisan support in Congress. Standing up a robust domestic lithium battery supply chain will not be done overnight. It may take a decade or more to accomplish. Whatever plans and recommendations LiveBridge makes will need to survive multiple changes in administrations and congressional delegations. We all need to keep this firmly in mind as we take up this task. I look forward to working with all of you in industry, as well as with NatBat's partners, New York Best and New Energy Nexus, and making sure that you in industry, the true experts in business and lithium battery technology, have a chance to share your wisdom and experience. Together, we can all help move our country, its economy, and the world as a whole in the right direction in this new age of electricity. Thank you very much.
Jim, thank you. That was fantastic. I think many of you have seen Jim in many forums, and he's been fantastic in sort of telling us this story of how the industrial part of the United States can sort of lead and ensure that we're able to do something that can create this market for the future, make sure we decarbonize, but also capture the industry. So thank you for those comments. And as I was mentioning before, Jim and our partners in New Energy Nexus and New York Best have been fantastic in pulling together where we are in LiveBridge. And stay tuned for a lot more details on LiveBridge, as you heard. It is now my absolute pleasure and honor to introduce our next speaker, David Howell, who really needs no introduction, but I'm going to spend 3 minutes introducing him anyway. Dave, as many of you know, is the director of the Vehicle Technologies Office in ERE in DOE. But as of last Friday, he has an additional job. He will be the acting director and principal deputy director of the Office of Manufacturing and Energy Supply Chains. This is a new office, probably 2 months old, if I can remember correctly. And they are in charge of the infrastructure funding on aspects related to manufacturing and supply chain. So much of what we're talking about in the bipartisan infrastructure law, the BIL, is really something that Dave is going to be thinking deeply about in his new role. Dave and the Vehicle Technologies Office have had a steady hand in guiding the R&D and the industrial strategy for batteries for many decades now. Dave came to DOE from Oak Ridge National Lab around the time I started the National Lab System. So I want to say 2003. You may want to correct me if I got that wrong. I actually remember the first time I met Dave. It was at a review meeting of what is called the Advanced Technology Developmental Program, the ATD program, if I remember correctly. So that goes back a long time for those of you who've been in this industry for going in 20 years. Dave has been a great partner for the battery community. He's been through this whole in the 2000s, looking at the ARA funding days. I remember in the last decade, he was organizing people from the national labs and industry to give feedback on what needs to get done, how can we build a strategy, and he's continuing that trend now with the infrastructure bill and where we should be going as a country in order to capture this market. With that, Dave.
Hey, thank you for those kind words, Venkat. And yeah, it's been a while. I think I do remember the first time we met way back in 2003. And we've come a long way, as we all know. So one of the things that the LiBridge Alliance and their organizers wanted me to do is give you a brief version of the presentation that I provided in the plenary session yesterday. For those that were not able to attend the plenary session yesterday, we do have a lot of new participants today because we have new topics. And so I do refer to yesterday's plenary session, which was recorded, that not only includes remarks from the Argonne National Laboratory Director, Paul Kearns, but the Department of Energy's Deputy Assistant Secretary for Transportation, Michael Berube, and myself. So in this brief, it's really focused on how the bipartisan infrastructure law is poised to support the buildup of the battery supply chain, including innovation. So with that, next slide, please. So briefly, Michael Berube provided more details on the Department of Energy's mission to decarbonize our economic sectors, including the transportation sector and electric grid sector. So I do refer you to his presentation yesterday for those details. But one of the things I do want to point out, if you go to the next click, is that across any of these modes, whether it's transportation, electric grid, industry, buildings, and even ag, high capacity batteries have a significant play in enabling us to decarbonize. And specifically, obviously, for electric vehicles, it's a critical technology. There's not really a pathway to decarbonize transportation sector without high capacity batteries. And of course, then for the electric grid is certainly a key enabler as well. So next slide. Hopefully you've seen this slide before out of either the national blueprint that Jim mentioned that was developed by the Federal Consortium for Advanced Batteries, or our 100-day supply chain report from the President's executive order for high capacity batteries. But the trend, this just shows you the trend, looking at all of the projections, either of high capacity batteries, global expansion of high capacity batteries across the world, and that manufacturing capacity expansion, it's all poised to grow. And this is what we're seeing. If you go to the next click, we see that growth happening today, point blank. You see a pathway from 59 gigawatt hours of US manufacturing capacity for advanced battery cells, moving toward 224 gigawatt hours by 2025 from the announcements that we've seen. This is a year old. So over the past year, there's been several additional announcements that would actually bump that number for 2026 to 340 gigawatt hours. So significant growth is happening, and our efforts with the Department of Energy, with the LiBridge, with the FCAB is to make a smooth path for that transformation of our economy. Next slide, please. So I mentioned the 100-day supply chain report. Hopefully you've had a chance to peruse it. The Department of Energy had the privilege to lead that, but it was certainly a federal government effort, federal-wide, looking at the risk associated with the battery supply chain. for the United States, whether it's an upstream or midstream or downstream risks. And that upstream, obviously, from raw materials production and refined materials to processed materials to midstream, component processing and manufacturing, cell manufacturing, all the way through pack manufacturing and end-of-life recycling and reuse. Right side there, you see the key vulnerabilities that were identified in the upstream and early midstream. No surprises here. Class 1 nickel, lithium, and cobalt are certainly the primary supply chain vulnerabilities, but there are other concerns as well. And there's additional vulnerability in the mineral refining and processing space as well. Moving down to midstream, cathode and anode production capacity is sorely lacking in the United States. And the US global market share, as Jim mentioned, across all major battery components and cell production is minimal. Downstream, we lack incentives to help the market and improve market demand for lithium batteries, and primarily driven by EV demand, as you see. And of course, there's a huge vulnerability in our lack of a national lithium battery recycling strategy. Today, less than 5% of lithium batteries are recycled each year. So the supply chain report provided significant recommendations back to the federal government on how to address and mitigate some of these issues. And next slide, please. In addition to that, yeah, go ahead and click. One more click. I was going too fast. Okay, thank you. The next slide, as Jim mentioned, the federal consortium's blueprint for lithium batteries was released in June, along with the supply chain report. And again, this was a teamed effort between the federal agencies in the federal consortium. And our goal is to help establish a secure battery materials and technology supply chain for the United States, not only for commercial applications, but for defense applications as well. Within that blueprint, there are 5 key goals. And again, sort of mirroring what we did in the supply chain report: minerals, battery materials, cells, packs, recycling, and innovation. Within those goals, we outlined the key actions that the federal government agencies can take in unison or even in our daily missions in order to address those key issues that were identified. So we're off and running, developed working groups within the federal government. The FCAB is represented by 5 leadership agencies: the Department of Energy, Department of Defense, Department of Commerce, and the State Department. But it's broader than that. There's about another 13 agencies involved. And within those 17 agencies, there's about 50 offices that have a stake across those agencies in the battery supply chain. So we're all marching and marshaling our forces to address those key issues that were identified within the blueprint and the executive order supply chain report. Next slide, please. And so that brings us to the bipartisan infrastructure law and how it plays. And hopefully this is no surprise to people. The bipartisan infrastructure law included significant provision to support the build out of the battery supply chain, as you see here. Section 40207B, named battery material processing grants, provided $3 billion of federal funds over the next 5 years to focus on mostly separation of materials from extracted feedstocks and materials processing and refining. And then that money will be matched by industry. So that $3 billion is a minimum $6 billion play over the next 5 years to install manufacturing capacity in that space. In addition, 40207C, battery manufacturing and recycling grants, includes another $3 billion over the next 5 years matched by industry to address manufacturing build out in these other areas, whether it's component processing like cathode processing, anode separator, electrolyte, or cell manufacturing, pack manufacturing, and the establishment of recycling plants for lithium-ion batteries. There's an additional section, 40208, as you see there. It's a research, development, and demonstration section in the BIL, and it's for electric drive vehicle battery recycling and second life applications. And that's 200 million over the next 5 years to do that research, development, and demonstration in this space. So I'll provide a little bit more detail in each of these sections in the next few slides. Next slide, please. So, so concentrating on 207B and 207C, I did want to point out that, you know, we do have some significant provisions on what that money is to be spent for, as shown here on this slide, and it's very similar. You know, that money is for to support projects in these three areas, whether it's demonstration projects, new commercial scale facilities, or to retool, retrofit, or expand existing facilities. 207B is, you know, focused on materials processing, as I mentioned, and 207C on the battery manufacturing and recycling grants as well. But you see also within the bill, you see these are major projects. The amount of the grant awarded under the program should not be less than, and this is federal dollars, 50 million for demonstration projects. So that's basically a minimum of a $100 million demonstration project in these areas to scale up new technologies. $100 minimum, $100 million minimum for new commercial scale facilities. $50 million federal share minimum for retooling, retrofitting, or expanding existing facilities. So that language was given to us by Congress, and you know what you'll see in the funding opportunity announcement that we're building out right now will emulate this direction, among other direction within the BIL. So next slide, please. So just speaking briefly on what's in what we're thinking through on 207B, battery material processing grants. Two major tranches of activity here that we see. One is to support domestic mineral separation of extracted feedstocks. Those are materials like, you know, like lithium, like cobalt, nickel, graphite, these things, and other materials that are important to a domestic battery supply chain. But in addition to that, it's materials and facilities important for the refinement and purification for battery grade materials, the things that go into battery components. As you see here on this list, it's certainly not an exhaustive list, but it certainly is examples of areas that we'll be funding under 40207B. And of course, I mentioned that scale up and demonstration activity associated with non-conventional resources of minerals specifically, and other things of that nature. Next slide, please. And for 207C, battery manufacturing and recycling grants, similar story, you know, establish domestic manufacturing and recycling facilities across the United States to support the battery supply chain. Areas of support include state-of-the-art lithium-ion battery cell production, cathode active material production like NMC and LFP and other materials, anode active materials separator production, and recycling facilities, as you see here, including pack and cell teardown. We do want to service other areas, alternative battery technologies if possible, and other production plants that are not included in those above, like pack assembly, electrolyte mixing, and binders and current collectors and things of that nature. The scale up and demonstration focus will be on next generation technologies, whether it's materials and processing technologies that would drive down the cost of conventional materials, you know, improve the efficiency of making those materials, or next generation technologies like silicon anode active materials and electrodes, or lithium metal and solid state materials as an example. Next slide, please. And so hopefully, as all of you know, we did put out a notice of intent in this area, had 12 proposed topics here that pretty much emulate what I just mentioned. And so we do appreciate all your feedback yesterday and today in these specific areas to help as we build out the funding opportunity announcement in this space. So your input is important as we build these topics out. I will point you to our frequently asked questions in our partnering list. That's part of that notice of intent. So please feel free to add a question to that FAQ so we can respond directly and publicly to those questions. And there is a partnering list associated with the NOI. If you don't think that you're an applicant, a major applicant or a prime applicant, but would love to support an applicant, obviously, please feel free to put your company name on the partnering list as well for others to see your interest. Next slide, and I'll try to finish up here in just a few minutes so we can remain on schedule. I do want to talk about the electric drive vehicle battery recycling grants research and development program. Next slide, please. This was, again, some language that we were given. Second life applications and the development of technologies and processes are the primary focus of section 40208. You see what processing means here and recycling means. It's given to us by a definition in the BIL. And so next slide, please. I just want to emphasize the importance of recycling in this entire supply chain, and the ecosystem has the potential to provide significant amounts and quantities of key materials for batteries going forward here. And at the same time, reducing the cost to manufacture materials, reducing the energy and water needed, and reducing emissions associated with battery materials production. So recycling is a key part of our strategy. And, please enter in and participate in the recycling space as well. Next slide. And notice of intent, again, same story. We had a notice of intent to come out the same day as the previous one, February 11th, specifically focused on two areas. No surprises here: recycling, processing, and reintegration of materials into the battery supply chain, and second use scale-up demonstration projects. There is a FAQ associated with this notice of intent as well. And then the last slide. So this is our schedule. I mentioned the notice of intents that came out in February. We are on track to release a funding opportunity this spring. So stay tuned. We're not only building that funding opportunity out, but then we'll start working its way through the necessary approvals within the Department of Energy as we march toward releasing that funding opportunity. And obviously in the summertime, applications will be due, probably midsummer, and then in the fall we'll do the evaluations and hopefully have selections announced by mid-fall. So with that, last slide, I just want to thank everyone for your participation. Thank you for taking the time out to provide input to us through these videos. Those are very important. The Department of Energy is in listening mode. Our federal consortium partners are in listening mode. So we really appreciate you taking the time to participate here. Again, I just want to one last time thank Argonne and Liebridge for organizing this meeting. So with that, Venkat, back to you.
Thank you so much, Dave. That was fantastic. It was a encore performance only because it's so important and the audience is different for today's AOIs compared to the ones yesterday. So there are a few questions that have come in, Dave. If you look at the Q&A part, and it's interesting to sort of see that people are already engaged in sort of having the conversation on workforce, on what can we do to build manufacturing. So thank you. That was deeply appreciated. So we're now going to move to this other part of sort of listening to what the industry people's perspective is in terms of what is needed for US manufacturing. This is going to be a series of recorded presentations, as I was telling you before. We'll start from AOI 6, just to remind everybody, if you came in yesterday, you saw 1 through 5. If you did not, remember that after the meeting at some point, we will share those recordings with you, so you'll have a chance to see what happened yesterday. Today, we're going to go through AOI 6 through 12. We'll start at AOI 6, which is going to be focused on lithium-ion battery cell manufacturing. So you will hear a series of videos, and the moderator for this session is going to be my colleague and friend from Idaho National Lab, Eric Dufek. So Eric?
Thanks, Venkat. So as Venkat mentioned, I'm Eric Dufek. I'm the department manager for our energy storage and electric transportation department here at INL. Really, if you look at the history and where we have focus and interest in batteries, it really stems to all the way back into the mid 80s of trying to understand what life and performance of new and emerging technologies actually looks like. Personally, one of my main interests is how do we much more discreetly move things from kind of the base level of, going all the way from kind of benchtop to the consumer. in an enhanced rate. I think that's something that's extremely important now. It's something that we have to do very effectively and efficiently as we look at, kind of building up the manufacturing chain, building up the supply chain as well, because that's really what's going to allow us to maintain that global competitiveness and actually make the impacts that we need. Where that actually wraps in is in AOI 6, we're mainly going to be focused on looking at commercial scale domestic lithium-ion battery cell manufacturing. That's extremely important. There's a lot of needs that actually come into this. There's all the downstream items that, where do you actually get the materials for the actual manufacturing? And then there's kind of the tail end of how do you actually get those into the hands of consumers and end users. Because of the number of applicants in this area, we've kind of split it into 3 different sets of slide decks. So the first one's going to be mainly focused on kind of traditional lithium-ion technologies and actually looking at how we do that manufacturing, whether it's low or no cobalt, whether it's actual normal high energy cell designs, both at the cell and the pack level. The next area kind of focused on a lot of the next generation or kind of unique battery fabrication. And then the last one is really going to be on support information. So if we actually move forward to looking at what's going to be in the first area, we've got 6 different companies that are going to be kind of rolling through. And with that, let's go ahead and move into the videos.
Hello, I am Paul Charles, the CEO and President of American Battery Factory. We are standing up a nationwide network of decentralized, clean and green, modular and safe lithium iron phosphate cell gigafactories. Each ABF cell factory provides 300 and up to 1,000 new high-paying jobs. The question today is, how should the United States invest in the American battery ecosystem? The short answer is strategically, as this is a matter of national security. We believe all individuals, neighborhoods, utilities, states, and sovereign entities should have the ability and freedom to create, store, and deploy their own energy through battery storage. The most important element in the battery supply chain ecosystem is to have customers, which means supporting cell manufacturers in America that produce safe cells without conflict materials in ESG-centric environments while prioritizing U.S. raw material suppliers. The U.S. should support cell production, which uses lithium iron phosphate chemistry, or simply LFP, not just because it's an American invention, but because it's safe, mature, low cost, has wonderful longevity, can be 100% charged, doesn't contain nickel or cobalt, which is a near conflict material primarily provided by child slavery. LFP cells are ideal for use in multiple markets, including the following 3. First, electrification of a wide range of transportation modes, such as trucks, buses, and agriculture vehicles. Number 2, energy storage. And number 3, U.S. military and government applications. There is no volume production of LFP cells in America today. U.S.-made cells are absolutely needed now in massive volumes and will continue to be in demand for many years to come, especially as the chemistry is enhanced with U.S. innovation. American capital markets should embrace U.S. cell manufacturing. Also, the U.S. government should provide loan guarantees and grants in a rapid processing mode to support the CapEx heavy, fully automated robotic factories. Just to give you an idea of cost, American Battery Factory's modular gigawatt plant start at about $500 million and grow to about $1.9 billion or more. With a national network of decentralized factories, government financial support would go a long way in scaling American cell production capacity and allow U.S. companies to compete with Europe and Asia, where vast amounts of government capital are currently available. The U.S. is about a decade behind Europe and double that of Asia in creating a battery ecosystem. The U.S. can absolutely leapfrog ahead to a position of global leadership if we take a distinctly American cooperative approach to this challenge. We're actively looking to form partnerships with the U.S. government, laboratories, and R&D centers, along with those both upstream and downstream American suppliers of battery materials and services. Please join us.
Hi, my name is Dr. Deanna Ahmed. I lead strategy and government relations at One. We are an energy storage company headquartered in Novi, Michigan, with 100 employees, and we've raised $95 million to date. We are taking our first product, Aries, into production end of this year, and we have 25 gigawatt hours of book business over the next 5 years. So I'm here to talk today about who One is at its core. So One is founded on the idea that range anxiety is the singular barrier to adoption for electric vehicles in today's market. So we have set out to double electric vehicle range as a mechanism to facilitate the paradigm shift that an EV can be your only battery. Our ability to increase range is through our novel architecture, which pairs 2 battery chemistries to accommodate both the daily driving needs as well as the extended driving needs that consumers can find themselves engaging in on road trips. So Gemini 1 was our prototype of our Gemini architecture, and in January we demonstrated 752 miles of range on a single charge. What we are also working to do is to leverage safer and more abundant materials in our chemistries. So in doing so, we are leveraging 95% more sustainable chemistry, more sustainable minerals in our Gemini architecture, where a leading consumer EV pack right now is leveraging close to around 50% of more sustainable materials. So in using less lithium, no nickel and cobalt, and less graphite, we're able to also accommodate that vision that electric vehicles can one day dominate the transportation market. So in looking at range in miles, and both considering EPA rated range as well as real world range, both Aries and Gemini are market leading products. Aries represents a lithium iron phosphate structural battery that is going to be entering into production end of this year. And Gemini is that dual architecture. Both of these are nickel and cobalt free. Our goals to increase our manufacturing capacity include the standing up of a gigafactory. We're right now engaged in our site selection study, and our vision is to be able to be producing at scale in the next 5 years. And that is going to yield over 2,000 manufacturing jobs, high-paying manufacturing jobs, and the company itself, in terms of its engineering infrastructure, is going to double in size this year. We believe that this will be a $2 billion CapEx investment, and it will grow from there, from start of production up to full capacity within several years, and continue to scale as we work to expand our market. So what One is doing is really working to become a US battery or energy storage company.
Hi, this is Shailesh Upreti, founder and chairman of C4V and IM3NY. And today I'm very excited to share how we are driving the growth of lithium-ion battery ecosystem in North America. A quick glance to our journey so far, from our birth to the start of our first gigafactory going live this summer. Our first commercially available technology is a cobalt and nickel-free, high-safety lithium-ion cell built with a solid domestic supply chain. Our cathode, anode, electrolyte, separator, and are all manufactured in the US. Our vision is supported by 200 plus raw material and equipment suppliers today. We have raised good amount of capital to support our vision. At IM3NY, we have also secured large cell supply contracts. A strong R&D and manufacturing team has taken in charge to make it happen right here in America. A solid domestic platform not only includes an advanced R&D activity, but also a full smart manufacturing solution to scale the manufacturing up and drive costs down. We are aiming to grow to 38 gigawatt hour as the first gigafactory start ramping up to its nameplate capacity of 1.8 gigawatt hour this summer. As we build a cost-effective domestic solution, we strongly believe market buys what is available and not the best. We continuously innovating cobalt and nickel-free solution to support the market needs, including cobalt and nickel-free solid-state solution. Here is the quick demo of our system-level solution with our exciting BMLP technology.
We are C4V, innovating molecules to machines to establish a lithium-ion battery technology ecosystem. Today, we are introducing LISA, A unique cell technology platform, LISA brings to you a cobalt and nickel-free lithium-ion battery cell technology, providing 40 to 50% higher energy and 5 times more power density than LFP. LISA is the first ever tabless prismatic design delivering extra-fast charge benefits. With cell-embedded cooling loops, LISA eliminates the need for a complicated thermal management system. The low carbon and toxic footprint makes LISA one of the greenest possible battery technologies. Built with a robust domestic supply chain, the profiled architecture makes LISA one of the best designs for a solid structural stability of a battery pack. LISA brings freedom from modules to deliver an industry-leading cell-to-chassis and cell-to-pack performance, exceeding majority of the packs available in the market, irrespective of the chemistry. LISA Tech also comes with an inherent exceptional safety owing to C4V's oxygen-deficient BMLMP chemistry. C4V committed to deliver safety and performance with LISA.
My name is Nathan Millicum. I'm the CEO of Electric Power Systems. We currently provide energy storage systems. We provide modules and then charging services and infrastructure focused on the aerospace industry. So EP Systems is a category leader in providing electric propulsion systems focused specifically on battery modules and integrated pack designs. We are going after a $3 trillion marketplace, and we are currently backed by some of the most reputable and credible investors in the world, such as Boeing, Safran. We also have one of the largest automotive manufacturers. EP Systems is looking at a large-scale manufacturing site in the United States. Specifically, we want to manufacture modules, packs, and then take cell manufacturing in-house. Our current cell manufacturing supply chain is in Asia, and we have a strong need to grow that supply chain and build it domestically to serve both our domestic and European customers. Packs typically last on an aircraft 1 to 2 years, and if we can't replenish those packs that are flying, then the fleet is grounded. So we have to look at battery manufacturing almost like a refinery. We need those resources domestically to be able to continually support our industry. Some of the unique technologies that we have are containment systems that make energy storage safe for aviation, as well as controls and power management solutions that make it low cost and efficient to travel by air. Challenges to US manufacturing is specifically around workforce training, getting the specialty supply chain over into the United States, and then really scaling to meet the strong demand that we see in aviation. Our business requires a broad skill set. We have need for assemblers, we have need for professional people, we have need for engineers and even PhDs. Primarily to the manufacturing site, we need people who know automation very well, who can run complex machines. These jobs are high paying and very resilient to changing economic conditions. So we've already reached out to a number of stakeholders in the community, including our different municipalities that we operate in, our county and our state legislatures, and then even our federal representatives. We have broad support throughout these different communities to be able to build this within Utah, where we're currently located. It's estimated that aviation will contribute to 15% of all global emissions by 2050. But more importantly, general aviation is the last remaining industry that still uses lead in its products. And that lead is highly toxic. It's traced to cognitive disabilities and is particularly harmful for children.
Hi, my name's Harold Rust. I'm the CEO of Enovix Corporation. We're a Fremont, California-based battery manufacturer. We're a US-owned company. We've developed an advanced silicon lithium-ion battery that delivers significantly higher energy density than other batteries. We've spent about a decade of R&D getting our technology to this point. and we're commercializing our batteries in 2022. We went public last year and are building a strong track record of delivering cells to customers this year in the consumer markets. We've also received a grant award from the DOE and are working on cells that will be going to the DoD. So that's an exciting development. When we think about the EV space, our first reaction is that it's a challenging place to start as a battery company. It's obviously one where you have to be a massive scale with significant capital requirements, challenging margins to start, and long development cycles to qualify products. It's for that reason that we as a company are initially targeting the consumer electronics space. That said, there's not a huge difference between, building a battery like this for a wearable or potentially something like this for a laptop device. These batteries are in principle very much the same other than their size. And to make larger cells as well that you could put in something like an EV is really not a fundamentally huge technology challenge. There are some challenges, but it's really more a challenge of scaling the company to be large enough to compete in that space. And so, our goal is to get into that space, but we believe that, support from the federal government would allow us to enter it sooner. And so we'd like to see the DOE support technologies and business plans from a diversity of markets, all the way from consumer electronics to EVs, and support, the capital costs, for those companies to be successful and to create a domestic battery market. It's promising that the DOE has acknowledged the need for domestic cell and pack manufacturing support, which is obviously the core of the EV supply chain. When we think about the supply chain in general in the US, we try to go to great lengths to maximize the US content of our cells, and firmly believe the DOE should incentivize US content of that whole supply chain to grow a robust market domestically. Many elements of the US lithium-ion battery supply chain are underdeveloped. They just don't exist. All the way from mineral extraction to refining and to cell and pack manufacturing, even to sales. And we firmly believe the DOE should call for US content requirements to put the entire domestic supply chain on a firm footing. Not just the endpoint of the sale of the EV, it's really about everything along the way. So thank you for the opportunity to talk today, share our point of view. We definitely look forward to working with the Department of Energy to accelerate the development of our domestic supply chain for lithium-ion batteries and to scale as a company to get to the larger EV market as soon as we can.
Lithium battery is a vertically integrated manufacturer of cells, rechargeable and non-rechargeable battery packs, and modules, serving the industrial, medical, robotic, military defense, and energy end markets. Lithium battery develops and manufactures highly differentiated lithium iron phosphate cells, modules, and battery packs. Lithium battery is currently finishing the construction of a new lithium iron phosphate R&D and cylindrical cell manufacturing plant in Henderson, Nevada. The cell facility has a capacity of 60 megawatt hours per year. This cell operation will be producing high-performance LFP cells for the medical, aviation, and military markets. Given the lack of domestic sources of high-quality LFP, Lithion currently sources its LFP from Vietnam and China. The facility will also focus on the development of formulas, qualifying suppliers, and fine-tuning manufacturing processes for a much-anticipated prismatic facility. The advancements made here will greatly reduce the ramp-up time when the new facility opens for production. Beyond our Henderson cell facility, Lithion anticipates a sharp growth in the commercial, industrial transportation, energy storage market. We are exploring to build a 400,000 square foot, 4 gigawatt hour per year cell manufacturing facility. This facility would fall under Area of Interest 6 or 12. Domestic availability for lithium carbonate is limited. North America has not historically been a significant producer due to a lack of developed resources. With an increased global demand, spodumene deposits in Canada and Nevada and brine deposits in Nevada and Mexico, or even synthetic methods, can be explored. Developing North American suppliers of critical materials components, and infrastructure, including state-of-the-art equipment, will help to address the current supply chain issues. On the supply chain side, the U.S. has strong competencies in material science and chemical engineering, but lacks an experienced cadre of engineers familiar with the synthesis and production of battery materials at the industrial level. Continued and increased financial support for this community is critical to remaining competitive in the lithium-ion battery industry. Lithion is committed to building its LFP cell manufacturing facility in an economically disadvantaged area and achieving the goals of the administration's Justice 40 program.
All right. We're going to, as we kind of get ready for the next transition into kind of the next generation chemistries, as well as some unique fabrication techniques, I just want to remind everyone that you can reach out to a lot of these different companies through the chat, and be sure to send any questions our way. All right, let's go ahead and move to the next group.
Hello, my name is James Treavy. I'm the CTO of Forge Nano and excited to share with you what we're doing. Forge Nano uses a nano coating technology to finish materials such as cathodes and anodes, which enable significantly improved battery performance. I'll be speaking to you now about our plans for cell manufacturing, though you will see another video from Forge Nano as part of this session, which focuses on our intent to enable improved raw materials and reduced environmental impact over current state-of-the-art technology. Forge Nano has been working with numerous industry and DoD partners the past decade to develop and build leading cells for a number of niche applications. We now have supply contracts to deliver our cylindrical cells and are planning to build out our production capabilities to meet that demand with our U.S. dominant materials supply chain, which we've already employed to deliver cells for Space Force and are already in space. Our challenges are not a surprise. To execute on our existing and growing number of agreements, we must obtain funding for equipment, materials, and testing, as well as hire and train a complete workforce. We have U.S. and allied partnerships already in place to execute our plan, and just need funding to move things forward to be able to deliver our products sustainably. We're already working with local universities and national labs, as well as the state government, to develop our labor force, and our company was actually founded to address environmental issues. We already have a long track record of successful engagements with the DoD and DOE, and intend to provide a medium for future workforce training and data sharing to ensure national energy security. We have plans in place to deliver the safest and highest quality cells, and have a flexible product adoption model to enable the most timely adoption of these industry-leading batteries. With that, I appreciate your attention, and I'm excited to answer any further questions. My name is James Treavy. Please email me if you have anything to follow up about. Thank you.
Hello, I'm Mitch Koffel, the EVP for Business Development at Nanoramic. Nanoramic started in 2009 out of MIT with government funding. We initially focused on ultracapacitors and used this platform to develop our electrode technology. In 2019, we saw the opportunity to transition the technology to batteries. As you can see in the red box, our neocarbonics technology has been very successful in lowering cost, increasing energy density, and delivering faster charging. The core of our technology is the removal of PVDF polymer binders and the toxic NMP solvent. Neocarbonics is a 3D carbon binding structure. It has worked with all cathodes we have tested, including NMC, LFP, LCO, and others. On the anode side, we have developed silicon anodes with more than 50% silicon. You can see an example of our current energy density for NMC with silicon. We are greater than 320 watt-hours per kilogram and 820 watt-hours per liter. Our research shows additional increases of more than 10%. Neocarbonics is an environmentally friendly technology. Since there are no plastic binders or toxic solvents, the recycling will be more efficient. The manufacturing process uses eco-friendly solvents, and the faster drying time uses less energy. Overall, we estimate a 30% reduction in the energy consumption, leading to a lower carbon footprint. The Gigafactory will combine Nanoramic funds with North American customers. We're asking the customers to invest in the factory to secure supply. The more they invest, the more supply they control. We will then request a matching grant from the US government to complete the funding. This amount of funding will allow us to build a 1.5 to 3 gigawatt hour factory in the US. Our goal is to have a versatile factory with longevity. We are targeting flexibility with different electrochemistries and various cell types. For certain legacy products, such as those required by the DoD, we will continue to use industry standard PVDF where necessary. To move forward, we must find partners who will invest a minimum of $10 million for their guaranteed production. This could be, again, DoD, other underserved markets, and limited prototyping for EVs. Site selection is focused on brownfield, disadvantaged communities, and stable, low-cost power. We must work with and help establish raw material supply in the US, and we need to secure government funding. Our Nanoramic Gigafactory has supply chain flexibility, which will support US sources. It will be climate friendly and will create a good long-term jobs in local economy. Thank you very much. Please contact me with your interest.
Hello, my name is Gaurav Jain. I'm from Medtronic, the world's largest medical device company. You may be wondering, why am I here at the Lithium Bridge Conference? Suffice to say, batteries are critical to meeting world's healthcare needs. And batteries are really the fuel for innovation in medical technology. And that's what I'm really here to talk about. And my ask is to make sure that in this Lithium Bridge endeavor to develop North American battery supply chain, medical devices are not forgotten. And the support for medical devices is kept front and center as these developments go forward. So let me share with you a few examples of the types of needs we have and how this can really work out. Here is an example. This is an implanted pacemaker. Medtronic serves about half of world's implantable device needs. We make our own batteries for implantable devices here in Minnesota. So about half of world's implantable batteries are made right here. In this case, this is a tiny battery that goes inside a pacemaker, which is inside the heart and keeps it beating for over 12 years in most cases. This is technology that we have developed internally, but we rely on a lot of suppliers for the materials and many of the components that go inside the battery. A different example, this is a wearable product. So, imagine a patient with diabetes or a child with type 1 diabetes, where the parents have to do multiple pricks to measure their glucose levels and be worried about, their long-term health. And contrast that with a wearable device that mitigates that concern for the patients and the child. Ventilators, here's a different area, but again, batteries are critical. We don't want, if there is any interruption in power, we don't want the ventilation supply to get interrupted. And hence batteries in most designs are necessary to run the ventilators. You put it all together, what this means is we are really dependent on battery material supply and battery cell supply, battery pack supply. We have strong partners in Asia today, but as we look long term, we'd love to partner with the broader industry and this initiative here to first bring our own expertise to bear in this initiative for long life batteries, for highly reliable batteries, but also help develop suppliers and through strategic partnerships with other industry players and suppliers to make this area healthy for this part of the world, and also be able to serve our patients who are critically dependent again on battery technology for their needs. Thank you.
My name is David Mechanic. I'm the CEO and founder of Anthro Energy. At Anthro Energy, we are utilizing advanced polymer materials to create batteries that are flexible, safe, and high performance. Our vision is to create conformal energy storage to power the next generation of wearables, medical devices, flexible electronics, IoT devices, and more. We are currently in the prototyping phase and are commercializing our technology with support from the Activate Fellowship, funded by the DOE, and the National Security Innovation Capital, funded by the DoD. We are currently shipping prototypes to customers via our demo kit. Anther Energy's plan to scale up involves contract manufacturing, as our battery fabrication process utilizes the same equipment and steps as conventional battery cells. However, according to our knowledge, there are no large-scale battery manufacturers in the United States who specialize in making lithium polymer pouch cells in sizes appropriate for wearables and consumer electronics. This has forced us to look overseas for manufacturing and scaling partners. At Anther Energy, we believe that developing domestic manufacturing capability to power our smartphones, medical devices, wearables, and IoT devices is as important as developing manufacturing infrastructure for EV cells. In addition to funding infrastructure for low to medium-sized pouch cells, we also need to invest in battery manufacturing technicians to operate these lines. Small-sized batteries often require more customization compared to automotive batteries, creating a need for more battery engineers and automation engineers. These batteries are often sold for higher margins compared to EV cells, which opens opportunities to create high-paying jobs within the community. At Anther Energy, we have a long-term vision of strengthening the domestic LIB supply chain by building out our own pouch cell fabrication line. This will be critical to power our connected devices and further U.S. innovation in power sources for these important applications. Thank you.
Hello, my name is George Little, and I work at Lighten, an advanced materials and EV battery company based in Silicon Valley. We're a 7-year-old company that exited stealth mode late last year. We've raised over $200 million in funding, and we believe we're cracking the code on how to develop commercially viable lithium-sulfur cells. And the way we're doing it is by using a completely new carbon material that we've invented and patented. We call it 3D graphene. Our plans for establishing U.S. manufacturing are ambitious. We're well along in building a pilot production line at our main factory site you see here, and we expect it to be completed and operating sometime this summer. It will have the capacity to produce over 200,000 cells, or roughly 150 megawatt hours per year. Of course, we anticipate this being a stepping stone to building a US-based gigafactory sometime later. So here on the left, you see an electron microscope image of our 3D graphene, which can be thought of like a regular sheet of 2D graphene, but crumpled up, kind of like what you get when you crumple a sheet of paper. As I mentioned, our 3D graphene is a key ingredient for our lithium-sulfur cells, which you see on the right side. We're able to make our cells as either pouch cells, cylindricals, or prismatic cells. One unique aspect of our cell manufacturing is that our supply chain will be entirely North America-based. Our cells don't use nickel, manganese, or cobalt, so we don't need to import nickel from Russia or Indonesia, or cobalt from Congo, or refined materials from China, like you see on the left side of the slide. We just use sulfur, which is readily available in the US, and we use natural gas, which is also readily available in the US, and which is the precursor for making our 3D graphene. As the slide mentions, a third party's research report states that our cell manufacturing carbon footprint will be 60% lower than that of traditional lithium-ion batteries. One challenge we're facing is sourcing lithium metal. So one suggestion we have regarding government help would be to fast-track permitting of new lithium sites here in America. There are several projects under development, like Salton Sea in California and the Thacker Pass project in Nevada. These are just examples, but our main point is we need permitting timeframes that are counted in months, not in years. The critical path length to producing lithium is already long. Shortened permitting would be a huge help to domestic battery producers like Lighten. That's all for now. Before signing off, let me just express Lighten's thanks for this opportunity to provide input to LiBridge, and we hope that it contributes to our collective efforts to build a top-notch battery supply chain right here in America.
All right, so we're just about ready to get going on to the third set of videos in this area, and this is going to be a slight transition away from kind of actual manufacturing the cells to a little bit more focused on the actual equipment you need to support cell manufacturing. All right, let's go ahead and move forward with the video.
Hello, my name is Oliver Harman and I am Technical Director at Miltech. Miltech UV is a well-established manufacturer of industrial UV curing equipment with global customers in many industries. We're a privately owned small business on the East Coast of the US and have been in business for more than 30 years. For a little over 10 years, we've been developing UV curing technology for the lithium-ion battery industry, trying to bring the typical benefits of UV to this industry. Miltech's patented UV curing technology improves over current manufacturing processes for battery components in a number of ways. Firstly, we seek to remove toxic solvents from the coating process, making lithium-ion battery manufacturing safer for employees and less damaging to the environment. Miltech's technology allows to substantially reduce the energy use and increase manufacturing speed with smaller equipment requiring less floor space and lower initial investments. These features allow for a significant reduction of manufacturing cost. Battery performance is equal or better than the legacy technology, and we focused to reduce the risk of implementation by making the technology compatible with most existing or planned equipment. From our perspective, the US battery industry faces a number of immediate challenges. Today, the US industry and research facilities seem mostly focused on development of the next generation battery technology. However, in order to compete with global manufacturers in the existing and growing market right now, we're lacking the required infrastructure and manufacturing facilities. Making things even more challenging is the limited capacity of US-based and international equipment manufacturers to even support the projected growth. In order for the US industry to gain an advantage in the global market, manufacturing processes and their improvements are key. However, bringing new battery manufacturing processes from the lab to industrial scale requires levels of investment that small and mid-sized companies often don't have. Bridging the gap between research and full-scale production will be vital. The situation for Miltech is such that we are seeing strong commercial interest in our products and technology. Unfortunately, however, much of that interest comes from manufacturers outside of the US. We would strongly prefer to work with US organizations to help those gain a cost and environmental advantage over global competitors. Also, unfortunately, we found it to be easier to demonstrate the use of UV technology and bridge the gap to manufacturing by using partners outside of the US. Our recommendation is for the US to focus on the here and now. Implementing cost-effective and environmentally responsible processes are needed to compete with international manufacturers. We will have to rely on scientists, engineers, and a skilled workforce to accomplish this, so education, particularly focused on the manufacturing aspects for batteries, will be vital. Equipment manufacturers need support to help the US industry grow at the projected rates. And finally, we need independent facilities supporting small and mid-sized companies such as Miltech in our
Hello, my name is Stefan Pilutek and I'm introducing Bühler Battery Solutions. Bühler is a global process technology company with activities in advanced materials, and here we have battery solutions, as well as consumer foods and grains and food divisions. Bühler as a company has sales of about $3 billion and a workforce of roughly 13,000 people. It's a 100% family-owned company. In North America, our regional headquarters are located in Minneapolis, Minnesota, and we employ roughly 700 staff in North America. We not only have sales offices, but also several service stations, manufacturing sites, and application centers. In the field of battery manufacturing, we offer two distinct solutions. One for precursor and raw materials grinding, including for silicon grinding or LFP grinding. I would like to focus here on our solution for fully continuous electrode slurry mixing, which is a comprehensive solution starting from raw material intake raw material dosing, and the mixing process itself, where Buhler offers a whole mixing plant. This is a highly productive technology. We have more than 10 years of experience in this. This technology allows a fully continuous production of electrode slurries at an excellent dispersion quality. It's applicable to all electrode formulations, for example, LFP, NMC, NCA, but also solventless or solvent-free formulations. We've already realized lines with more than 2,000 liters per hour productivity, and we've installed more than 50 lines worldwide. Now, we would like to bring this innovative technology also to the United States. A main challenge in this is a certain reluctance of established manufacturers to adopt newer technology. We see that some players rather stay with established and therefore outdated mixing technologies. With our approach, Buhler's workforce requirements include engineers as well as manufacturing staff, both on the mechanical side as well as on the electrical side. And in addition, installation staff for maintenance, and of course, operations. I look forward to a discussion. You can find additional information on Buhler's battery solutions here and reach out to me at stefan.pilotek@buhlergroup.com. Thank you.
Hi, my name is Rudy Berry. I'm the founder and CEO of StatPeel. We are a Swiss-American manufacturer of analytical instruments to monitor airborne contamination in laboratory and production environments. I'm sure you're aware of the toxicity of some of the materials you're working with. Working with harmful material means to make sure you have as little release as possible. Obviously, in a production environment, you have to put all the necessary engineering controls in place. Nevertheless, it's very critical to monitor exposure even in such environments, because you cannot be sure that you have no release. To ensure the health and safety of your employees, you have to conduct aerosol measurement campaigns. Today's instruments cannot tell you the harmful contaminants among all the other background particles. Personal exposure monitoring is a laborious and slow process. People have to wear heavy pumps with large filters, which are then sent to a lab for inspection. To address those issues, we came up with an integrated system. It's called the identifier. There are three components to the identifier system: a filtration slide as a consumable, a wearable badge, and a benchtop reader with a built-in Raman spectrometer and an industrial PC. The system can be operated by any user without any prior training necessary. The system features lightweight badges that can be worn throughout the day to measure personal exposure. The loaded filters are inspected by the reader, and the exposure is calculated right away. This means you get fast results and all the data remains in-house. As said before, the identifier can be operated by any user, but only the health and safety specialist has access to the data. With the rush to build up the huge production capacities needed to transition to electromobility, it is extremely important not to forget about health and safety. I think it would be a worst-case scenario for the industry, by rushing to meet the green and sustainable goals, that the workers involved would pay with their health. If you want to evaluate the capabilities of the identifier, try out our sampling kit at your location. Please take a look at our flyers and videos to learn more about StatPeel, the identifier, and our sampling service. Thank you for your attention.
At Thermo Fisher, with 100,000 colleagues around the world, we are committed to innovation and delivering global thought leadership. Our experts are continually developing new solutions to meet the evolving needs of our customers. We are dedicated to advancing science through R&D investments and staying ahead of innovation. We take pride in our mission. At our core, we are scientists, and our purpose is to enable our customers to make the world healthier, cleaner, and safer. And supporting the clean energy market segment is a priority for us in achieving our mission. Our broad range of technologies provides solutions across the battery development, quality control, and manufacturing pipeline. We execute innovation in 6 continents with a deep portfolio and infrastructure that makes us the leader in serving science and supporting our customers' operations. Thermo Fisher's capabilities for serving the battery value chain stretch from lab to line. We deliver advanced technologies enabling customers to develop new materials for the next generation of batteries, characterize and control production materials, control the production process through advanced metrology, assure battery production, formation, and assembly, inspect and release assembled cells, investigate failures, inspect and recycle or reuse cells. Our analytical characterization solutions serve the needs of the battery industry in R&D, quality control, process control, and failure analysis areas. Micro-CT is the key tool for non-destructive analysis to check the defects in the cell production environment. Aviso software provides visualization and quantification on the CT data. Electron microscopes, including SEM and dual beam, provide essential imaging capability for quality checks on the raw materials and failure analysis during electrode or cell production. Raman and FTIR are powerful techniques to study chemical and conformational changes, providing important insights for battery material quality control and failure analysis. Finally, ICP OES is the key QC step for impurity analysis during the battery production process. Our inline process metrology and control capabilities enable battery manufacturers to accelerate production, improve product quality and safety, make process decisions faster, and protect their brands. Our inline metrology systems monitor and help control the uniformity of electrode coating, thickness of calendared layers, and consistency of extrusion and coating of separator films. We support our customers' smart manufacturing initiatives with our cloud-based instrument performance monitoring technology. We also continue to innovate. Last year, we launched the Thermo Scientific Linspector measurement and control system, an inline metrology platform designed specifically for the battery industry, and this year, we have more exciting innovations to come. Thank you. To learn more, find us at thermofisher.com/battery.
All right, that wraps up AOI 6. So now we can go ahead and hand it back to Venkat.
Eric, thank you so much. I appreciate it. And I want to thank all the companies that had these presentations and for the engagement through the chat window. Keep that going. I mean, obviously, all the people that are presenting are in the audience waiting to see if anybody has any questions. We also have a lot of people from the federal government that are online. So any comments and feedback you might have, please use the chat window to move that along. So Eric, thank you so much for bringing us to this point where we are actually on time. We're actually 2 minutes early. We have a break now for approximately 10 minutes. We're now at 1:04 Chicago time. We have a break till 1:15, so approximately 11 minutes. I'm going to suggest that we take the break. When we come back, what we're going to do is my colleague from Brookhaven National Lab, Esther Takeuchi, is going to be the moderator. And she's going to cover 3 topics, AOI 7, 8, and 9. So this will be cathode manufacturing, separator manufacturing, and silicon anodes. And once we finish that, my colleague from Oak Ridge National Lab, Ilias Belharouak, will be going through AOI 10 and 11, and then we go on the next break after that. So let's break for exactly 10 minutes, come back at 1:15 Chicago time, 2:15 East Coast, where we'll continue with AOI 7. Esther will be our moderator. Thank you all.
People smile and tell me I'm the lucky one, and we've just begun. Think I'm gonna have a son. He will be like she and me, as free as a dove, conceived in love. Sun is gonna shine above. And even though we ain't got money, I'm so in love with you, honey, and everything will bring chain of love. And in the morning when I rise, you bring a tear of joy to my eyes and tell me everything's gonna be alright. Seems as though a month ago I was beta guy, never got high. Oh, was a sorry guy. But now I smile a face, a girl that shares my name. Yeah, and now I'm through with the game. This boy will never be the same. And even though we ain't got money, I'm so in love with you, honey, and everything will bring a chain of love. And in the morning when I rise, bring a tear of joy to my eyes and tell me everything's gonna be alright. Pisces, Virgo rising is a very good sign. Strong and kind, and the little boy is mine. Now I see a family where there once was none. Now it just begun. Yeah, we're gonna fly to the sun. And even though we ain't got money, I'm so in love with you, honey, and everything will bring a chain of love. And in the morning when I rise, you bring a tear of joy to my eyes and tell me everything is gonna be alright. Love the girl who holds the world in a paper cup. Drink it up. Love her and she'll bring you luck. And if you find she helps your mind, buddy, take her home. Yeah, don't you live alone. Try to earn what lovers own. And even though we ain't got money, I'm so in love with you, honey, and everything will bring a chain of love. And in the morning when I rise, you bring a tear of joy to my eyes and tell me everything's gonna be alright.
forget the sun in his jealous sky as we walk in fields of gold. So she took her love for to gaze a while upon the fields of barley. In his arms she fell as her hair came down among the fields of gold. Will you stay with me? Will you be my love among the fields of barley? We'll forget the sun in his jealous sky as we lie in fields of gold. See the west wind move like a lover soul upon the fields of barley. Feel her body rise when you kiss her mouth among the fields of gold. I never made promises lightly, and there have been some that I've broken, but I swear in the days still left, we walk in fields of gold. The children run.
We are about time to begin. Just want to confirm that Esther is back.
Hi, Venkat.
Perfect. Take it away, Esther.
So hello, everybody. My name is Esther Takeuchi. As Venkat kindly introduced, I'm the chair of the Interdisciplinary Science Department at Brookhaven National Lab. I'm also a professor of materials science and chemical engineering at Stony Brook University. So it's such a pleasure to be here today and participate in this two-day event that I think is so important. And we're really on the cusp of accelerating and ramping up domestic battery manufacturing and improving the supply chain. So this is just a wonderful place to be. I'm going to be moderating information on AOI 7, 8, and 9, having to do with cathode manufacturing, separators, and then silicon anodes. Many of you probably who know me know that I spent the first 20 years of my career in a battery manufacturing company. We made lithium batteries for specialty applications, such as implantable medical, and we just heard a couple of words about that a moment ago, but other specialty applications, including downhole oil exploration, oil recovery, even outer space, all requiring very special environments and special conditions for the batteries. But even though the batteries were different, and in many cases, the ones we made were not rechargeable, in terms of manufacturing, several themes to me came through loud and clear. And I wanted to mention a few of those because we've been hearing these themes, pop up during the course of yesterday and today. The first one I'll comment on is really incoming materials, consistency of supply. Getting a consistent material, how do you know it's consistent? What I found is electrochemistry is so sensitive that many other characterization techniques, even though they tell you nothing's changed, the electrochemistry changes. So then how do you know that you can use that material for your battery in the long term? Will it work? Will it work well enough? The second thing I wanted to comment on is quality assurance, really the design, whether this is a component or the battery itself. How tight do the windows need to be? How robust is the design? How resilient is it to changes in process? And that leads right into quality control. Setting those parameters and keeping within the design parameters is really critical. But if the parameters are set too tight, it leads to increased scrap, increased costs, more complicated process equipment. But if they're not tight enough, then you get variability of output that is just not acceptable to you or your customer. So all of those things are really important. The final thing I'll mention in terms of running a manufacturing company is shifts in the marketplace. The market, as we all know, is not static, and the ability to respond quickly and respond to those shifts in the marketplace is really critical to be able to stay on top of manufacturing. So as I said, this is a wonderful time to have a renewed focus on battery manufacturing to really accelerate what I personally believe has been a need for a long time. And here it is in front of us. And I'm really looking forward to hearing more about the information on cathodes, separators, silicon anodes, and I see the chat is generally active, so keep your questions coming. This is a wonderful time for everybody online to engage and participate. So if we can go to the first video.
Hello, this is Chris Abram from Hit Nano. We're a small business based in New Jersey, and we want to share with you our battery cathode manufacturing technologies with a view to developing fruitful partnerships to scale up these technologies in the United States. So we began in Princeton University in 2017, and our mission is to develop environmentally friendly manufacturing solutions for high performance energy storage materials for electric vehicles. So we've 3 relevant patents on the technologies I'll be talking about. We receive funding from the Department of Energy and actively collaborate with academic and industry partners in the materials, batteries and electric vehicles area. So we are providing solutions for the next generation of cathode manufacturing. So the co-precipitation route is the prevailing cathode production technology and is dominated by countries such as China, Korea and Japan at present. So in this process, metals are processed into metal salts, which is itself an energy intensive process. Sulfate salts are then fed into the co-precipitation reactor, which requires additional chemicals and generates wastewater, which requires energy intensive processing for recovery. So in other words, this is a time consuming, capital intensive and environmentally damaging process that needs to be updated. We have 2 technologies which are completely different. First, we're working on an aerosol synthesis process. It forms a lithiated active cathode material with low energy and no additional chemicals in a rapid process step. Second, we're working on a direct metal oxidation to cathode process. This process completely eliminates the conversion of metal to metal salts, which further reduces the time, the environmental impact, and the cost of the cathode material significantly. Turning to the first of these technologies, the aerosol method is very flexible for designing novel materials with precise ion doping. So as shown, we can achieve selective ion precipitation, which forms a concentration gradient structure. This improves the thermal stability and the electrochemical performance of the material. Moreover, this method has a very broad compositional flexibility, is fast, and it requires no additional chemicals. In the second method we're working on, direct metal oxidation to cathode. From a manufacturing standpoint, this method is truly single step. It completely eliminates 2 major steps in co-precipitation by working directly with metals, and it's fully compatible with existing plants, so it makes scale up very straightforward. So we can use this method to produce gradient structure, high performance, cobalt free and nickel rich materials. In summary, these are 2 technologies which have the potential to transform conventional cathode manufacturing, and we are looking for partnerships to commercialize these technologies and establish environmentally cathode manufacturing here in the United States. Thank you.
I'm Bob Backrack, co-founder and senior vice president of eJoule Incorporated. eJoule is a California company with world headquarters in R&D center in Fremont, California. The pilot facility with 200 metric ton capability is in Hsinchu, Taiwan, and the first 1,500 metric ton production plant is in China. Today, I'm submitting comment for Area 7, advocating investment in high-volume lithium-ion cathode active material U.S. production as part of the proposed FOA 2678 in support of the bipartisan infrastructure law, battery materials processing, and battery manufacturing funding. High volume is defined by supportive of typical vehicle OEM production targets of 500,000 EV per year, or 50,000 metric tons. eJoule has developed disruptive, scalable synthesis process flow for high-volume manufacturing of lithium-ion cathode active material. The eJoule process flow goes directly from solution of all the chemical components to crystalline cathode powder. Comparison with the Argonne National Lab analysis of the incumbent hydrothermal precursor CAM calcination to CAM process flow finds the eJoule process is cost competitive while yielding high performance cathode powder. The eJoule expected burden product production process cost is estimated to be 10 to 15% below the published figures. The eJoule process is particularly suited to incorporating dopants directly into the solution, which are essential to achieving high energy, low to no cobalt compositions. eJoule process flow is based on proprietary equipment and chemistry developed in the United States, which produces high performance, price competitive cathode active material. The high throughput unit equipment module is compact, energy and water efficient, and configured for zero emission. Because the plant minimum economic unit is 500 metric tons per year, an eJoule plant can be built in sections which can produce customer-specific compositions. eJoule equipment can be dry cleaned and composition changed in a matter of days. eJoule has done a conceptual design study of a 50,000 metric ton CAM plant which can be built in any suitable location in the United States with joint venture or DOE teaming partners. eJoule strongly advocates DOE including funding for CAM production as part of the FOA 2678. CAM production is essential to establishing the lithium-ion battery supply chain. I appreciate the opportunity to make these comments and look forward to
Hi, this is Mark Gresser, CEO of Wildcat Discovery Technologies. Today I'll be talking about our technology, our plan for U.S. manufacture, and some of the challenges we're facing. Our company was founded in 2007. We've built a unique high throughput platform for the research and discovery of new materials for the battery industry. We've been doing this and working with companies throughout the supply chain for over 10 years now. And in the past 3 or 4 years, we've been working on new material technologies for ourselves, and we plan to take these to the market by 2024. The 3 big internal targets we're working on are the Wildcat cathode, a high energy cathode that contains low cost materials, contains no nickel, no cobalt, and has the potential to be 56% more energetic than today's best cathodes. We're also working on a solid state electrolyte, and we're also working on lithium metal protection strategies. Our plan is to manufacture both the cathode material and our solid state electrolyte materials in-house here in the United States. That puts us sort of dead center in the supply chain shown here. Some of the challenges we face. Significant capital is required to make this plan a reality. We've raised quite a lot ourselves. We're hoping to get some grant money and some additional funding in the coming 2 years as we scale up and show that our technologies are ready for commercialization. We think it's important that the DOE invest not just in the manufacturing, but also in R&D and product development, which must go hand in hand with the manufacturing to ensure U.S. supply chain sustainability. We're having difficulty hiring people for various roles in our space. Very few scientists have work authorization for the U.S. Our government could make that easier, at least as a short-term solution. We'd like the DOE and our government to provide more funding for STEM opportunities, especially early in grade school in particular, we think would be very, very useful. And we also think that scientists should be encouraged to do PhDs in very practical technologies, battery chemistries, and technologies that the industry is using today, not far out materials or ideas that could happen in 10 or 15 years. Because we just aren't finding people with relevant experience. These are our recommendations. This is a summary of our company. We thank you for your time.
Hi, my name is Vivas Kumar, and I am the CEO and co-founder of Mitra Chem. We are an American lithium-ion battery materials product company focused on solving 3 problems. Number 1, reducing the design build test cycle to bring a new cathode product to market from 18 months down to 1 month or less. We accomplish this goal by leveraging an in-house machine learning advantage built on the same principles of research from our co-founder and Stanford professor, William Chu. Second is to work on iron-based cathodes, which reduce our dependence on nickel and cobalt specialty chemicals materials based on a supply chain that is mostly in China today. And finally, industrializing these cathodes in purpose-built facilities for large-scale manufacturing right here in the United States. Today, we are constructing our lab in Mountain View, California, which is where we will be able to accomplish all aspects of design, building, and testing, all the way up to 10 kilogram batch runs by the end of the year 2022. And by the end of 2022, we will also be able to prove a 1-month design build test cycle to get towards new iron-based cathode products that meets customer specifications. Our plan then is to build and co-locate pilot scale capacity to show industrialization potential by the end of 2023, and then ultimately work with an American customer to build a large-scale facility to fit within a vertically integrated supply chain hub right here in the United States. There are 2 problems, and there are 2 ways that we're thinking about this large-scale manufacturing. So the first is jobs. Job creation will be for specialty chemical talent, which inherently has a high economic multiplier. There are already many regions within the United States that has this kind of talent that we could target in terms of our expansion. The second is in the cost of energy and in the proliferation of increased renewables. Over 50% of the cost of manufacturing iron-based cathodes is in the consumption of electricity. And if we could pair our facility with a region that has large and growing renewables penetration, or with a government mandate for increasing renewables for industrial applications, we can bring down the cost of our product to be more competitive with those of made in China cathodes. Considering that the United States has almost zero capacity for commercial scale production of cathodes, we would like to be at the forefront of solving this problem. We would like to thank NatBat, LiBridge, Argonne, and the Department of Energy for this opportunity, and we look forward to working with you and multiple other players to build the American battery supply chain.
Hi everyone, this is Shane Thompson, the president of Retrieve Technologies. Retrieve Technologies is one of the oldest and largest lithium-ion recyclers in North America. Our facilities are in Trail, British Columbia, and in Lancaster, Ohio. That facility in Ohio was actually co-funded with money from the Department of Energy to fund the recycling of lithium-ion batteries. Where we currently are, or we're producing a material called a black mass, where the nickel and cobalt are recovered. But those materials, generally speaking, don't make their way back into the battery supply chain. From a technology standpoint, we understand that this is the critical ingredient in a domestic supply chain for the production of batteries, is the availability of supply. So what we're doing is we're currently walking down a technology pathway where we'll introduce more hydrometallurgy on site. That will be happening this year. That will allow us to both process more lithium ion, but also to create a more preferable material, an upgraded material. Ultimately, our goal is to get all the way to new cathode production. We've talked about this in a joint development agreement with 6K Energy. They have a process for making cathode that we think is potentially very disruptive. So for us, operating a TSDF Part B facility, so we operate a fully permitted environmental facility. We understand the collection and transportation. We've got some very interesting synergies with our partner companies, Heritage Crystal Clean, Heritage Environmental Services. We recently acquired Battery Solutions. All of these create logistical advantages. We see eventually the numbers getting so large that regional processing will start to become a more and more important part of the long-term battery recycling equation. So from a technology standpoint, we definitely, funds that would help growth would be a welcome addition. We're also looking at testing capabilities to kind of rapidly assess the state of health of batteries so we can determine which batteries go for recycling and which batteries can be used for second life. So we're making some investments in what we call 2L, or second life, and finding applications where the batteries may be better suited as energy storage devices. And then we're working down the path on the technology side to make sure that ultimately the material gets back to new cathode. So we're looking forward to that endeavor and happy to talk more about specifically what we're doing there in Ohio and Southern California. Thank you.
Hello, my name is Sam Tretch, and I'm the president of 6K Energy. We are all aware that there is zero battery material production in the United States, and as we invest aggressively to address this, 6K believes that if we invest solely in today's technology, it is ultimately not a long-term sustainable solution. We believe that we must invest in transformational technology to ensure that battery material production and the associated jobs do not ultimately flow back to China, thus idling major capital investments. 6K is based on a technology derived from the MIT Plasma Science and Fusion Center. The company now has over 120 employees and is raising $150 million, of which a significant portion will go towards deploying our US-based manufacturing plants. We have 126 patents, which cover the equipment all the way through the processing of the material on the equipment. We are currently installing systems in our pilot facility outside of Boston, which will have the capability to provide enough powder to support 400 megawatt hours. So how do we do this? If you look at the far left flowchart, that is an example of today's process known as co-precipitation, which is a multi-step, multi-day process. If you look at the 6K flowchart, our technology is a 3-step process that uses 10% of the water. It uses a third of the energy, and it creates 0 solid or liquid waste, and essentially completes in 3 hours. So we collapse a 3-day process that is very energy, water, and waste intensive to a 3-hour clean process. By doing that, if you look at the chart on the right, we save multiple dollars per kilogram versus China on the conversion into battery materials. And we believe that it's this type of technology that is needed for a long-term sustainable industry. If you apply the savings to the 400 gigawatt hours of stated lithium-ion production in 2025 in the United States, and you run that for 5 years, essentially 2 terawatt hours worth of energy, you would realize a $10 billion savings from the processing of those materials. That savings is realized by eliminating the need to deal with 340 billion liters of waste, eliminating the need to use 300 billion liters of water, and eliminating 70% of the energy that's needed to make those materials, thus eliminating 30 million tons of equivalent CO2 emissions. A few points on this slide. Our commercial scale plant will require about half the land and half the plant square footage. This gives us a lot of optionality when selecting locations. Secondly, the technology is very modular, so you can start up and run as you're scaling. And lastly, the CapEx isn't tied to just one chemistry. Within one day, the same machine can go between running NMC 811 and then convert to LFP. So in conclusion, as the lithium-ion ecosystem grows in the United States, we must act now and invest in leapfrog technology to establish a long-term sustainable industry. 6K is positioned to be a leader in the battery materials manufacturing space and leverage the upcoming grant funds to deploy multiple plants, supporting multiple chemistries and upcycling recycled content for our partners. With that, on behalf of everyone at 6K, thank you for this opportunity to share our story.
Thank you to all the presenters. This was really outstanding to hear the creativity and the interesting solutions that are underway here in the United States. So next, we're going to turn to lithium-ion battery separator manufacturing, and we're equally excited to hear about the recent results there.
Thank you for the opportunity to share this input. Celgard is a global company headquartered in North Carolina. We develop and manufacture lithium-ion battery separators, and Charlotte is the home of our first manufacturing plant. We expanded to Concord, North Carolina, and are proud to bring over 45 years of membrane battery separator expertise to the industry. Our dry process separators are widely used in electric drive vehicles. We also supplied separator to energy storage systems around the world, and we're used in many specialty applications, including military and satellite batteries. Celgard has the broadest portfolio of dry process lithium battery separators, including monolayer, trilayer, and coated and laminated products. Market pressures are increasing in the United States from overseas competitors that receive government subsidies, primarily in China. To illustrate the point, battery separator produced in the United States has decreased from 17% to about 3% from 2015 to 2020. At the same time, subsidies from the Chinese government have propelled China from a 22% market share to a 52% market share. With this, U.S. separator manufacturing is declining, despite growth in the lithium-ion battery and EDV markets. One of the first items U.S. battery separator manufacturers need is some form of financial incentive if federally funded projects utilize U.S. components and suppliers. It is also imperative that we have government support in protecting U.S. intellectual property. We need to prevent copying and IP violation. Any U.S. funded project should exclude materials of suppliers that are infringing on U.S. IP. The third area of need requires funding to advance battery safety. We need improved safety standards for testing and battery performance. Grants are needed for U.S. companies to develop innovative products that improve safety and energy management of the battery. Funding is also needed to expand U.S. membrane separator production and improve existing processes. And we also need to invest in developing innovative separator coatings that can enhance the battery functionality. Funding is also needed to develop battery separator testing and laboratory capacity. We need cutting-edge R&D to advance separator functionality. There is also a very limited capacity to test batteries higher than 5 amp hours, and our U.S. testing capacity is limited. Additionally, we need to build out and expand our prototyping capabilities so that we can quickly test new ideas. Finally, we believe funding is needed to determine the recycling stream of batteries. In summary, CellGuard suggests funding be allocated to provide incentives to use U.S. battery separators and components instead of foreign imports on federally funded projects. Also, to provide better IP protection for U.S. suppliers, advance battery safety, support separator production expansion and process improvement in existing processes, expand battery separator testing and lab capacity, and develop the battery recycling stream. Thank you for your time.
Hi, my name is Sebastian Lang with Bruckner Group USA, representing Bruckner Maschinenbau, a member of the Bruckner Group. We design, build, and service production lines for the biaxial orientation of plastic films. We employ more than 2,600 employees worldwide, are headquartered in Sixdorf, Bavaria, founded in 1960, family-owned, and generate an annual revenue of close to 1 billion euros. Our production lines are used in packaging industry, same as for technical applications. Here in specific for optical applications such as LCD screens, solar backsheet panels, for electronics and capacitor films, and for lithium-ion batteries for battery separator film. A battery separator is a crucial part of any lithium-ion battery, no matter if it's cylindrical, prismatic, or pouch shape. The battery separator film separates the cathode from the anode. It comes with the ability of letting ions pass through while preventing shortcuts between cathode and anode. Currently, the global market separates as follows. Around about 90% of battery separator films are today manufactured in the Far East, in specific in China, South Korea, and Japan. In Europe, we see now the first battery separator film plants popping up, since battery separator film was identified of being of strategical importance for the European automotive industry. The US claims a market share of about 6%, while I need to comment here that those 6% are more dedicated towards specialty applications rather than state-of-the-art EV lithium-ion batteries. This is a picture of a lithium-ion battery made by Bruckner, where you see the finished product here at the end, which comes out as a white film, produced with a width of up to 20 feet, and is then further processed, which means coated and converted before it's then delivered to the cell manufacturers. This is how the entire layout looks like of one production line, starting here in the upper right corner with the extrusion, undergoing a biaxial orientation, then the extraction bath, the annealing oven, and the winding. Film thickness range is usually between 10 and 20 micron, film net width up to 20 feet, and a line speed of 330 feet per minute. Typical plant layout looks like that there are two battery separator film lines housed in one building with shared auxiliaries and respective downstream units. Here you see a typical production line in one of our customer sites in Far East Asia that is housing in total 8 battery separator film lines. We meanwhile concluded dozens of these projects successfully around the world.
Hello, my name is Brian Morin. I'm the CEO and co-founder of Soteria Battery Innovation Group. There's two things to know about Soteria. The first is that we have a technology that enables lithium-ion batteries to be inherently safe, and I'll show what that means in a second. The second is that we're taking this to market through an industry-wide consortium of over 115 different players, companies, and you can see some of them listed here. So what this looks like is the cells on the left are standard cells undergoing 4 different nail penetration tests. As soon as there's an internal short, they immediately ignite. The Soteria technology cells perform exactly the same, except they're much more damage tolerant. Same thing now with cylindrical cells. The top is a nail penetration, the bottom is a 90-degree crush test. Again, significant difference between the cells on the left, the standard cells, and the Soteria cells on the right. Our vision is to have inherently safe cells everywhere. And we're taking this to market and building a community that agrees with this vision. You can see on the left the large equipment and material manufacturers, 30 different cell builders in the middle, and then a growing group of end users on the right. Our vision is that everybody deserves lithium-ion battery safety. It's 4 things we do. The first is we put our technology out as an open innovation platform for those companies to innovate on top of. The next is our promise to the industry, which is to put the technology out under FRAND terms so that everybody has access to battery safety. The third is we set an uncompromising safety standard so people know that our cells will do what we say they will. And then for cells that can be certified to that, we're going to let the Soteria name and brand be the sticker on the outside that tells you it's got safe cells on the inside. Cut this out. There's several things we want to recommend. The first is this is a global industry and we can't stop it. So we need to support US companies that have a global patent portfolio, and DOE labs should file their patents globally so that US companies can export and have their technology protected. The next is environmental protection is not uniform globally. So the government should restrict and tax imported materials that are made with low environmental protection standards. The next is that battery safety is an issue everyone ignores, and they can't. We need to have uniform cell level standards that address the root cause of lithium-ion battery safety. And 2 more, the growth of EVs is going to be restricted by material availability, so we should emphasize components that use less material, nickel, copper, lithium, everything, and also emphasize components that are made with renewable resources. And then the last recommendation is that US development needs to be protected, need to continue working with foreign countries on IP protection and prosecution, including discovery, which today is not allowed in China. And then also streamline the process for enforcing patents at our borders at import. And that's it. Thank you.
ENTEC is a US-based, US-owned business designing and producing battery separators for global manufacturing since 1984. Today, ENTEC supplies almost 3/4 of the battery separators used to produce batteries for US automotive OEMs. Unrivaled as the largest US producer of lead-acid separators for aftermarket vehicle batteries for both traditional combustion engines and stop-start vehicles, ENTEC has leveraged our expertise to produce battery separators at our Oregon campus for the global lithium battery market for more than 2 decades. Our core competencies in material science and process technologies, along with our internally engineered, fabricated, and installed production equipment, make ENTEC uniquely prepared to successfully expand our US footprint to serve the growing domestic lithium battery demand. ENTEC is committed to playing a major role in establishing a robust and resilient lithium battery supply chain in the US and helping facilitate the path to achieving net zero emissions by the year 2050. And as the only domestic producer of wet-process lithium battery separators, the technology of choice for all electric vehicle and energy storage lithium-ion battery manufacturers, we serve key growth customers within the burgeoning domestic lithium battery space. ENTEC is the only integrated supplier of an unparalleled and robust product portfolio that includes lead-acid, lithium-ion, lithium metal, lithium primary, and sodium-ion battery separators, making our intellectual property more important than ever to secure resilient, onshore lithium battery separator capability and business continuity for the growing demand of domestic lithium battery manufacturers. Our proprietary IT software allows us to apply and track statistical process controls in real time and ensure traceability through to the battery cell. ENTEC's equipment division designs, engineers, fabricates, installs, and commissions all of our battery separator lines, making us a truly vertically integrated company, allowing ENTEC to be both agile and prepared to grow with the US demand for separators. Product and process development projects at our campus in Oregon and our recently expanded equipment fabrication facility in Henderson, Nevada, are the first steps in implementation of our plans to install significant additional capacity for the production of lithium battery separators in the US. We have also pioneered the commercial use of environmentally sustainable solvent and recovery systems, which will be integrated with ENTEC production equipment in our gigascale lithium separator capacity expansion plan. By supporting INTEC, the Department of Energy will ensure INTEC achieves U.S. onshored gigascale production of strategically vital lithium battery separator at a faster pace and at a greater scale than could be achieved without that support. INTEC will proudly play its part in meeting the impending national imperative to expand a sustainable and resilient lithium battery supply chain by up to tenfold by the end of the decade.
So that was really great. Very exciting to hear about the advances and the progress in separators as well. So the next topic that we're going to take on is next generation silicon anodes. So really looking forward to the exciting developments there as well. So if we could start with the videos, please.
My name is Markus Vogt. I am Global General Manager for Mobility for PPG. At PPG, our mission is to protect and beautify the world. The role of batteries in decarbonization cannot be overemphasized. This historic shift represents a tremendous opportunity for businesses at every level of the value chain. But it also presents profound challenges related to system performance, durability, safety, and cost. PPG's ongoing initiative is to help battery and component manufacturers accelerate the development of tomorrow's energy storage solutions. Our broad-based materials expertise covers virtually every area of lithium-ion battery design and construction, helping customers boost energy density, extend service life, improve safety, increase manufacturing throughput, and reduce cost per kilowatt hour. PPG is keenly interested in working with the DOE to stand up lithium-ion manufacturing in the United States. We see our technologies as key contributors to the domestic battery supply chain. PPG intends to bring value to the battery manufacturing space through our deep expertise in materials design and application. With our range of products designed to enhance battery performance and safety, we are exploring several areas of interest in the upcoming opportunity. The greatest alignment between our capabilities and DOE efforts to advance US battery manufacturing is an area of interest 2 and 9. Commercial scale domestic next generation carbon silicon anode active materials and electrodes. To enable domestic manufacturing capabilities, products will need to be commercially viable in short term, but also technologically advantaged to differentiate them what is currently on the market. Anode production is an area with significant opportunities for both materials and processing improvements. Thank you for the privilege of sharing this message. As you can see, PPG is well positioned to advance the development of full-scale battery production in the United States.
Hello, my name is Stefan Pilotek, and I'm introducing Bühler's wet grinding solutions for lithium-ion batteries. Bühler is a process technology company active in the fields of advanced materials with battery solutions and also consumer foods and grains processing. Annual sales amount to approximately $3 billion. Workforce globally is 13,000 employees, and it's a 100% family-owned company. Here in the United States, our regional headquarters are located in Minneapolis, Minnesota. We employ roughly 700 people in North America. We entertain not only sales offices, but also service stations, several manufacturing sites, and application centers. Bühler offers two solutions in the field of lithium-ion batteries. One is slurry mixing, and here I'm going to focus on lithium-ion battery precursor and raw materials wet grinding. High-performance wet grinding applies to lithium-ion batteries in several areas, including silicon nanoparticle manufacturing for next-generation anodes, also cathode grinding, as well as the raw materials for cathode material grinding, and finally also the grinding of ceramic particles to make separators. High-performance wet grinding is realized by using very small media, 0.1 millimeter or small. So media are the ceramic balls that carry out the grinding. It's also aided by realizing very high flow rates, as well as a very high power density in the grinding process. And this equipment is operated in recirculation mode. Efficiency is measured in how much energy we need in order to realize a certain target size, and Bühler's technology is able to reach a given particle size at less energy and therefore also faster. Bühler offers this high-end wet grinding technology with both our equipment and application know-how. A challenge for the adoption of this technology is the amount of capital that is required to realize production scale plants, for example, as the need for silicon material grows. Bühler's workforce requirements include mechanical and electrical engineering, manufacturing experts, installation and maintenance staff for this equipment, as well as the operators at our customers. Thank you. You can reach me at stefan.pilotek@buhlergroup.com for further questions.
Hello, I'm Michelle Tokars, Vice President of Partnerships and Innovation at the Cortec Group. The Cortec Group is an innovator of silicon-based advanced materials. We're developing a prototype lithium-ion battery with a silicon anode that improves cycling stability by introducing an engineered solid electrolyte interface in order to produce a high-performing silicon anode. Industry is demanding greater and greater performance from lithium-ion batteries, and all eyes are on silicon anodes to take us to the next level. The theoretical 10x increase in silicon anode capacity over traditional graphite anodes has been the main driver for silicon anode technology development. While silicon anode battery exploration has made significant progress on many necessary battery performance metrics, it has yet to achieve the cycling stability necessary to make it applicable for mainstream use. To date, silicon anodes demonstrate a significant irreversible loss of charge capacity from the first to the second cycle, especially when measures such as pre-lithiation are not employed. The Cortec Group is developing a prototype lithium-ion battery with a special silicon-based anode to address exactly this issue. As the development of an SEI layer is unavoidable, we are intentionally incorporating it as part of our design. We're developing silicon-based nanoparticles that address the solid electrolyte issue by incorporating an artificial SEI layer. The Cortec Group's cyclohexasilane molecule, CHS, is an ideal silicon precursor for manufacturing the nanoparticles necessary to engineer this prototype battery. CHS is liquid at room temperature and has a unique chemical reactivity, making it well suited to creating an engineered SEI layer. The Cortec Group also holds an extensive intellectual property portfolio, including a recent filing for a full utility patent for advanced silicon anodes. Finally, we have a seasoned team with technical capabilities and associated commercialization experience. We are also currently working with medium-sized manufacturers. We believe this positions us with a unique opportunity to provide the industry with the best solution to address the SEI layer issue, enabling us to greatly improve the cycling stability of silicon anode-based lithium-ion batteries. As we develop our unique silicon-based anodes, We will rely upon appropriate manufacturing partners, including anode manufacturers. The Cortec Group believes the silicon-based nanoparticles we're developing to address the SEI layer issue will vastly advance lithium-ion battery performance and efficiency.
Hello, I'm here today to talk about Sila's drop-in silicon anode technology. This is a material that completely replaces graphite in your lithium-ion cells and enables manufacturers to achieve about a 20% increase in energy density today, with further growth opportunities in the future. Very brief background on the company. We're founded about 10 years ago. We're headquartered in the Bay Area. We've got about 300 employees now, with a real heavy emphasis on PhDs. We've got about 200 patents pending worldwide. We own the core IP to enable low swell silicon composite materials. Other suppliers and their customers, they'll need to license this from us if you are not partnering with us directly. The partnerships that we have, Daimler and BMW are public partners today, but we've got many others that we're working with that we have not disclosed yet. As far as capital being raised, we've raised almost $1 billion to date, with the last $600 million coming about a year ago from today. As far as our product being in market, so this is the Whoop fitness tracker. We introduced this about 6 months ago with Whoop. You can buy this in the market, get it on the internet, and you see our material in market. And those of you that have been in a company where you brought a material from the lab to market understand that's a huge milestone to ship to market. As far as our EV production plans, we do have a new facility that we're planning to start producing in 2024-25. That's going to scale up to thousands of tons. In the past, we've scaled up twice, going from grams to tons. So we're quite confident we'll be able to scale this next big jump to thousands of tons. Capacity for about 100,000 EVs or 500 million mobile devices. As far as any challenges for us, I think we all are looking for inexpensive green energy. That's really important for manufacturing in the US. Another thing is anything to expedite permits with the government or local municipalities is also very much appreciated. For Sila, workforce requirements are, we're in the range of hundreds of employees for each site, looking for diverse backgrounds from high school education to all the way up to material scientists. So wide range of education levels. And then as far as community involvement in environmental justice, for us, our social mission is diversity, equity, and inclusion, and we take a great deal of pride in that. And then any other relevant information for establishing manufacturing base in the US, I think the most important thing is getting.
Hi, my name is Jeff Hellman. I'm the Vice President of Sales and Marketing at Nanograph. We are a silicon anode startup based on the south side of Chicago, and our proprietary silicon oxide enables world-leading energy density and industry-recognized form factors. Thanks to the drop-in nature of our material and state-of-the-art performance, we were able to develop the world's most energy-dense battery for the US Army together with our cell partner. The cell is a 3.8 amp hour, 800 watt hour per liter 18650 cylindrical cell. The 18650 cell is the workhorse for military battery packs, with estimates of 50 to 80 million cells used each year. Production of the cell will begin in 2022 for military battery qualifications and fielding. With the support from the Army, we are currently onshoring the production of our silicon oxide material from Japan to Chicago as part of the national efforts to create an American lithium-ion battery supply chain. Starting in 2023, we'll be able to produce our silicon anode material at a scale of 36 tons per year to support the needs of the Department of Defense. And we have plans to scale to 1,000 tons per year as demand grows for electric vehicle applications. This is very much in line with the recent notice of intent specifically Area of Interest 9, which is commercial scale, domestic, next generation silicon anode active materials and electrodes. As we move into our new facility on the west side of Chicago, we will double the size of our workforce and triple our annual production capacity. We will be expanding our production operations and research and development. This is going to drastically increase the workforce. We view this as an opportunity to bring high-paying green jobs to disadvantaged communities in our city. Not only are we onshoring the production of silicon oxide to the Midwest, but we are aiming to promote an ecosystem where American battery technology innovations can thrive and find a path to commercialization. We hope to be a part of bringing America back to the forefront of energy storage innovation. Not only will this promote national security, but it will stabilize the supply chain of a critical component to electrification and decarbonization. Far too often, differentiating technologies end up being copied overseas before they have the opportunity to thrive. To get ahead of this curve, America must take the lead on developing a domestic battery supply chain along with the battery production capabilities. It's critical that America moves today to ensure its access to battery power and storage that meets its requirements. This will require strategic support for the supply chain and the production infrastructure to assure its longevity. Thank you for your time, and please reach out if you have any questions.
Hello, thank you to all of the presenters in AOI 7, 8, and 9. That was very enlightening. I'm now pleased to turn it over to my colleague, distinguished scientist Ilias Belharouak from Oak Ridge National Lab, who will moderate AOI 10 and 11. Thank you, everybody.
Thank you very much, Esther. Delighted to be here. Again, my name is Ilias Belharouak. I'm distinguished scientist and head of the electrification section here at Oak Ridge National Lab. As one of my reminders to this audience and in relation to some of the topics of Area 10, we're very excited to see lithium-based batteries and solid-state batteries maturing, as Oronal was one of the early labs that had seen the birth of solid-state batteries back in the mid-90s. In our regional ecosystem, we're equally excited to see several companies announcing the establishment of battery and EV manufacturing in the state of Tennessee, totaling over $8 billion of investments and over 7,000 jobs. Like other sister national labs where we house unique facilities such as the manufacturing demonstration facility, the battery manufacturing facilities, those are funded by the Department of Energy and provide distinctive equipment and unique facilities to solve some of the nation's most compelling battery challenges. Personally, I have been in the area of batteries for the last 22 years. And let me say that I share with you all the excitement and passion, but at the same time, the sense of urgency. Thanks to Argonne National Lab for the leadership and the staff that work behind the scene hosting this event. Thanks to Department of Energy leadership, David Howell, Mike Berube, Betony Jones, and Shalanda Bakers for providing a holistic and compelling vision, not only on the battery supply chain matters, but also on a critical topic relating to equity, environmental justice, and workforce development. So we're gonna go now to the meat of what we're trying to achieve collectively here. Let's start with Area 10. This is on lithium-based battery components and packs. I'd like to remind the audience that you can use the Q&A to post your questions and feedback. We have representatives from companies in attendance to get that discussion going with you. Also, I would like to remind the audience that the Q&A will be posted after this meeting, so stay tuned for that. The topics that we would be really learning about in Area 10 range from topics related to lithium metal, anode foils, roll-to-roll processing, compatible polymers and liquid electrolytes, salt, solid-state electrolytes, binders, role of fluorine and fluorochemical chemicals in the battery supply chain, sensors, and so on. So delighted again to introduce this exciting topic, and let's go back to the videos.
Hello everyone, my name is Jun Liu, founder of Solect. I welcome you here today and look forward to telling you about this amazing company. Solect, founded in December 2018, is a rapidly growing battery tech startup company located right here in Greensboro, North Carolina. We are developing next generation battery components, which are lithium metal anode and its compatible polymer and liquid electrolyte systems. We understand and redesign lithium metal anode rather than lithium metal foil for rechargeable secondary battery application. Are you ready to dive into what we are doing here? Please follow me. As many of industry experts agree, lithium metal anode is recognized as being the ultimate anode material due to its large energy density and structural simplicity. However, it's not easy to fully utilize its potential in a secondary battery application due to some technical challenges, one of these challenges being lithium metal dendrite. However, we believe that Lithium X can mitigate the issue very effectively, even under quick charge conditions. Currently, we are in the process of scaling up this technology to a fully automated ultra pilot scale. Now, let me introduce Dr. Robin Walton. She's our Director of Operations, and we'll walk you through the facility and manufacturing plan.
Thank you, Jen. And I'm very excited to share with you our current status and upcoming plans for our facility. As of right now, we are occupying 15,000 square feet of space. Our 2,800 foot square dry room is where we produce our prototype product, Lithium X anode, and conduct electrolyte research. Our custom dry room was designed by local vendors who did not have previous experience. We now have a local partner ready to jump in and assist us. I think this is a perfect segue to talk about challenges. While North Carolina is well known for manufacturing, having a business-friendly climate, and for its first-class research universities, there's an insufficient number of workers with the necessary skills to support a battery ecosystem in North Carolina. As we develop our pilot line facility, we are also challenged in the way that there are few domestic suppliers across the board of the value chain. Relying on overseas vendors can prove to be very challenging due to cultural and language barriers, higher and hidden costs, shipping risk, long lead times, and unexpected delays.
As Robin said, we are facing various challenges in our business. Now that we are looking to further expand, and governmental assistance is essential to support emerging market demand. We are ready to build a team to fortify the domestic supply chain in the U.S. Let's come and work together for manufacturing success of the U.S.
Hi, my name is Emery Brown, and I'm a manager here at Sarah, and I'm here today to present you as to why we believe solid-state electrolytes materials are critical to the supply chain for electric vehicles. Enhanced energy density and safety are the driving force behind next generation all solid-state battery technologies. And the solid-state electrolytes are the core technology of these advanced batteries, serving as a separator and the ionic conducting material in that and the cathode and in some composite anode designs. Many of the major automotive OEMs have announced roadmaps for solid-state batteries in 2025 and 2035. And by 2025, it's projected that several hundred tons of solid-state electrolyte materials will need to be manufactured to meet this growing supply chain demands in the United States. However, this brings us to the question, where is it coming from? Most automotive OEMs plan to be all EV, all solid state by 2035, with numerous factories spread throughout the United States. However, only 2 companies in the U.S. have so far have advanced scale production of solid-state electrolyte materials, Amsera and Solid Power. And it should be noted that the other companies in the market are either not truly all solid-state or polymer-based, or have not announced the scaled solid-state electrolyte production to meet the growing supply chain demands. Amsera is pioneering the scaled solid-state electrolyte manufacturing with over 200 repeating customers globally and 1 million in annual revenue. Amsera has also fulfilled well over 1,000 orders of various sizes. And it should also be noted that Amsera is the only US-based material company to make our products commercially available while advancing scale production to meet the growing supply chain demands. Amsera has over 20 patent-related applications, with 4 DOE grants awarded with several more pending. Amsera is also in collaboration with multiple universities and national labs, and is also currently partnering with several automotive OEMs to meet their solid-state electrolyte. Amsera's R&D facility is located in Tucson, Arizona, where the dry desert is great for dry room operation, as it will lower costs and hopefully enables scale production solid-state electrolytes at a low cost. And Arizona is also a growing hub for high-tech component development thanks to the dry desert. Amsera also promotes a diverse workforce, and we project over the next 10 years, the scaled solid-state electrolyte manufacturing will create over 2,000 jobs, ranging from high school level technicians to PhD researchers. This would also be very beneficial to our local Native Indian nations and other minority groups. The scaled solid-state electrolyte manufacturing will expand the battery ecosystem in the American Southwest, bringing EV manufacturing and spent EV battery recycling to Arizona, creating more jobs, as well as promoting EV adoption. For more information, please contact us at www.amsera.com or directly at info@amsera.com.
Hello, my name is Jay Carroll. I'm the Regional President of Arkema Inc.'s High Performance Polymers business. On behalf of Arkema Inc., an innovative manufacturer of sustainable materials, we greatly appreciate the opportunity to provide this short video and hope that it is useful to the Department of Energy as it finalizes the upcoming battery materials manufacturing funding opportunity. We hope that we'll be able to participate in this opportunity, one that we believe is right in line with our background and experience. As a longtime supporter of the Paris Climate Agreement, we strongly support the efforts of the Biden administration, Congress, and many others to advance electric vehicles and their key supply chains in the US. We believe these efforts and other related actions will help reduce greenhouse gas emissions and help the world move to a more sustainable future, while also securing jobs and an American manufacturing base. Thanks again for this opportunity to share some of our thoughts on this important topic of battery materials manufacturing.
Arkema Inc. is a domestic manufacturer of PVDF, an essential material for battery binders and separator coatings. Lithium-ion batteries cannot effectively function without PVDF. The safety and performance of lithium-ion batteries depends greatly on the quality of the binder, as well as the quality of the protective coating on its separator, and PVDF is critical for both. As this map shows, there are significant and growing investments in US battery manufacturing, but too much of this key industrial sector remains reliant on binder and separator coating materials that are produced overseas. The Wall Street Journal, supported by Morgan Stanley Research, recently reported that although global battery-grade PVDF capacity will more than double between 2021 and 2025, demand will quadruple in the same time. Therefore, to meet this enormous demand growth and to protect US interests and ensure these materials are produced in a robust way in the US, we strongly support the eligibility of PVDF under Area of Interest 10, the Commercial Scale Domestic Battery Component Manufacturing Open Topic, as this will help support the necessary capital investments. Any project under this program will require proper coordination of regulatory requirements at the federal, state, and local levels. The recent supply chain uncertainties also underscore the importance of having the entire supply chain for key end-use products like advanced batteries be based in the US. As a manufacturer in the US, Arkema Inc. understands the workforce requirements that will be needed, and we have sought the support of a key state local economic development agency to help support workforce needs as well as environmental justice goals. In addition, university and public-private R&D assistance can help support the capital investments. In step with Arkema Inc.'s commitment to helping build a sustainable world, our EV battery and separator coating materials are produced without the use of fluorosurfactant processing aids, and we believe this is an important feature in terms of creating more sustainable modes of transportation. Arkema is also working with the DOE's Advanced Manufacturing Office to help develop the next generation of PVDF binders and separator coatings that will be manufactured in a cost-effective and sustainable way. Thank you for the opportunity to explain how our materials contribute to a strong U.S. supply of sustainable materials that are essential to building a sustainable future.
Hi everyone, my name is Vahid Sarajian from Edge Global Innovation, and we have developed a new generation of liquid electrolytes to solve their major drawbacks. The result is a new product that doesn't catch fire. It works under extreme thermal and physical conditions. It doesn't emit gas, and it's shock absorbent. We are currently running different tests on the samples, and we expect to finish the tests by the end of Q2 of this year. But so far, we're very pleased with the results. Our plan is to establish the manufacturing plant in Orange County of Texas. Orange County is an opportunity zone with low-income community in Texas, but it's strategically close to major industrial zones of Texas, like greater Houston area, and at the same time to Galveston as an export hub. So we're counting on Orange County of Texas. From a workforce skill requirement standpoint and complexity of the manufacturing process, they're both reasonably low. So we expect to be able to hire people from low-income community, train and educate them without major concern. So overall, the process is very straightforward. Our product is technologically very advanced, cost competitive, and it has some major advantages from technical and safety standpoints. And at the same time, it creates some stable and permanent jobs here in the US and in low-income communities. Thank you very much for your attention. Again, my name is Vahid Sarajian from Edge Global Innovation. For more information, please contact me at 979-229-5563 or email me at info@egigroups.com. Thanks.
Cora is a global leader in the development, manufacture, and supply of fluoro products headquartered in Boston, Massachusetts. Cora owns and operates the world's largest high-purity fluorospar mine in Mexico. We process this fluorospar at the world's largest hydrogen fluoride plant on the US-Mexican border, some of which feeds our specialty fluoroproducts plant in Louisiana. Fluorine is a critical element in the battery supply chain and is used in the production of battery salts, additives, and binders. Cora is actively developing fluorine-containing battery materials, leveraging its vertically integrated supply base. The supply chain for electrolyte salts is currently based in Asia. Lithium hexafluorophosphate is the electrolyte salt used in nearly all lithium-ion batteries. Chinese production of LiPF6 currently accounts for over 90% of the world's supply. As a result, LiPF6 represents a single point of vulnerability for the manufacturing of lithium-ion batteries in the United States. Cora is working on establishing a North American-based supply chain for LiPF6. The first phase would be to establish a North American LiPF6 production facility with a capacity in the range of 5,000 to 10,000 metric tons, which could serve up to 30% of the US demand by 2025. We plan to continue capacity expansions as the domestic market grows. Cora has the in-house engineering and technical resources, as well as strategic partnerships to ensure the development and implementation of best-in-class LiPF6 process technology. Cora will provide HF to its LiPF6 production facility from our North American mine. We will also actively seek to use lithium feedstock from recycled battery materials obtained from North American recycling sources. A critical aspect of LiPF6 production is the production and handling of HF. Cora has an established fluorochemical facility and team at each of our plants in North America, which has the experience producing and handling HF at scale. The addition of LiPF6 manufacturing to our existing production facilities, including the related permitting, site development, and process development, will be handled by a management team and employees with significant experience in safe manufacturing of fluoro products. Cora also has established procedures for training new workers as the LiPF6 manufacturing plant is brought online. Finally, Cora has a formal community engagement management process to involve communities and stakeholders.
Hello, my name is Mary Whitmoyer, XEV Venture Lead at the Chemours Company, and I'm pleased to share about Chemours and our work to advance electric vehicle battery technology. The Chemours Company, headquartered in Wilmington, Delaware, is a leading global provider of performance chemicals. We have over 6,500 employees spanning 58 locations that include both manufacturing units and R&D centers. And while our global footprint allows us to serve thousands of customers across 120 countries, the bulk of our operations are located here in the United States. Sustainability is at the heart of everything we do at Chemours. In 2018, we announced 10 aggressive goals to bring responsible chemistry to life by 2030. The goals are divided into 3 pillars and act as our guiding light as we invest in long-term growth opportunities that will drive to a more sustainable future. Our product portfolio and recognizable brands provide critical raw materials for diverse market segments. And our capabilities include a deep understanding of fundamental chemistry and an ability to tailor products for optimal performance. We are a leader in developing solutions that propel society forward, and this includes investment in electric vehicle battery competence and new products to support this space. Today's market is placing many demands on electric vehicle battery performance, manufacturing, and cost. And we at Chemours have solutions to enable the industry to solve many of these challenges. Our Teflon fluoropolymers, including PTFE and electrode binders, have the electrochemical stability to enable high voltage cathodes, while also allowing for the use of a solvent-free electrode manufacturing process that reduces both environmental footprint and cost. Chemours also has a supply of alternative carbon material as a potential precursor to battery-grade graphite anode active material. Chemours' manufacturing of our battery solutions is anchored right here in the United States. We produce Teflon fluoropolymers in our Washington Works operation in Parkersburg, West Virginia. And strong electric vehicle growth and expected adoption of the solvent-free technology will result in a growing need for our Chemours products at this site. At our mineral sands mining operation in Stark, Florida, we have vast reserves of our alternative carbon material. And in addition to our manufacturing facilities, Chemours has a new research facility, the Chemours Discovery Hub, designed for collaboration between Chemours, our customers, and the scientific and academic community, including our neighbor, the University of Delaware. I thank you for listening, and I encourage you to reach out to our team for any questions or collaboration.
You're muted.
You're mute.
Apologize. I was saying just many thanks to the representative of the different companies, the 6 that we heard from. Let us now move to the next batch of companies and presentations within the same area of interest, which is TEM.
Amphenol Corporation, headquartered in Wallingford, Connecticut, is one of the world's largest manufacturers of high-technology interconnect, sensor, and antenna solutions. Amphenol Sensors, a division of Amphenol, is a leader in innovative sensor technologies and forward-thinking measurement solutions across all major market segments. The Amphenol Sensors team has a history of working with the U.S. Department of Energy through the ARPA-E program and is excited to have the opportunity to submit a proposal for Area of Interest 10, Commercial Scale Domestic Battery Component Manufacturing Open Topic. Our sensing solutions monitor battery health, battery connectivity, and early warning of thermal runaway. Battery failures can result in an internal reaction that generates heat and chemical decomposition of the battery cell, which is known as thermal runaway. Our battery cell connection systems have built-in temperature sensors to monitor battery health and efficiency. Our Red TR product, which provides early detection of thermal runaway, uses two primary sensors, a hydrogen gas sensor and a specialized pressure sensor. Our challenge is to grow faster and become a true global market leader in battery management and safety. To achieve this and keep up with market demands, we need significant investment in production capabilities, new technologies, as well as localizing our complex supply chain. To remain competitive and rely less on overseas contract manufacturers, we would expand our production and engineering capabilities in 3 separate sites. The first is our facility in St. Mary's, Pennsylvania. Our St. Mary's community is ready to embrace fresh investment in manufacturing, which will bring new jobs to the area. The St. Mary's region leads the world in powdered metal products for the automotive industry and will be hard hit by the move away from internal combustion engine vehicles. At St. Mary's, we would invest in a production line for flexible circuits, injection molding, and production lines for our cell connectivity systems. For our Red TR early detection of thermal runaway sensors, we look to add the capability for hydrogen sensor element production, as well as surface mount electronic production lines. These operations are currently performed overseas. The next facility is in Fremont, California, where we have an existing MEMS fabrication plant. With additional funding, we would add capacity to move our pressure die manufacturing from Asia to Fremont. This will support the production of the Red TR sensor in St. Mary's, Pennsylvania. The third facility is in Mesa, Arizona, where we would further support the pressure sensor production by localizing operations such as die attachment, wire bond, precision gel and adhesive, precision overmold, and high-volume calibration in Mesa. Amphenol Sensors is determined to consolidate and defend its market position in the battery safety and monitoring application space. We would ask for funding to localize our operations quickly, improve our competitiveness, and become less reliant on overseas contractors. We have a track record of success and the skills to execute our plans efficiently. Thank you.
With more than a century of expertise, Stryten Energy is a leading manufacturer of energy storage solutions. Stryten has more than 2,500 employees that span across its 10 plants and 2 million square feet of manufacturing space located in the United States. Stryten provides high-quality lead, lithium, and vanadium redox flow battery solutions, as well as intelligent chargers and energy performance management software that power everything from submarines to subcompacts, microgrids, warehouses and distribution centers, cars and trucks, trains, telecom networks, and data centers. Stryten Energy stands ready to support the increasing need for economical, reliable battery solutions and to grow at the speed needed to meet the expected domestic demand in the future. Our clear strategic goal is to design, manufacture, and service the next generation of lithium products made in America, utilizing our groundbreaking, safe, and reliable lithium-ion energy storage technology originally developed for military applications. To meet the growing business and consumer needs for energy storage, we are working to commercialize and build manufacturing capabilities in the U.S. for our i6T lithium batteries, as well as modular and scalable lithium energy systems. Progress to date is exciting as we incorporate the best-in-class performance of the latest lithium chemistry, newest electronics, and modular scalable mechanical design with process automation in mind. To enable the U.S. to compete with China and other offshore providers, we need to fully utilize the very latest highly effective automation equipment technology in all our lithium production. State-of-the-art automation will enable U.S. manufacturers to achieve competitive lithium product cost and the necessary capacity to satisfy the rapidly expanding U.S. market demand, while also preserving U.S. jobs and transitioning to a high-tech manufacturing workforce. Stryten Energy proposes the DOE consider funding some of the top lead battery manufacturers in North America to accelerate the transition to advanced lithium manufacturing and significantly expand the breadth and capacity of a U.S.-based supply chain of modern energy storage products for the consumer, industrial, and military markets. This funding scope would include engineering development of lithium drop-in packs with highly automated manufacturing equipment and retraining our U.S. workforce. Funding should be prioritized for U.S. companies with an established manufacturing domestic footprint and a demonstrated ability to produce batteries at scale. Stryten Energy also suggests that funding is directed to companies with the manufacturing expertise and the financial backing to successfully bring new lithium pack production to market. For more information about Stryten Energy and our commitment to the clean energy transition through our end-to-end energy storage solutions, visit our website at stryten.com or contact us at stryten.info@stryten.com.
Just as we saw electric cars go from concept to reality over the last decade, we're right now witnessing the dawn of the age of electric aviation. To understand how big a deal this is, we need to look back at the birth of the jet age in the 1950s. Back then, who would have imagined that jet travel would connect all the corners of the world? Trips that had previously taken a week could suddenly be completed in the time it takes to watch a few movies. Over the last century, U.S. leadership in aerospace has been critical to its continued economic success. And as we speak, the aerospace industry is engaged in the next technological race based on the electrification of aviation. One subsegment of electric aviation, known as advanced air mobility, has been projected to create 280,000 jobs and add $115 billion annually to the U.S. economy by 2035. Aviation is one of the most difficult sectors to decarbonize, and electric aviation provides a zero-emissions path to doing that. At Joby Aviation, we've been flying full-size, all-electric aircraft since 2017, with over 1,000 flight tests, including flights of over 150 miles on a single charge. We've been working closely with NASA and the DoD as we develop these capabilities, and we're working with the FAA to certify these aircraft for commercial operations in just the next few years. We design and manufacture aircraft, batteries, motors, and other components on the California coast. And as we transition from development into production, we're taking these challenges and scaling our capabilities for mass production. At Joby, we are highly vertically integrated. We design, build, and test our own batteries, achieving higher energy densities, longer life cycles, and faster charging. We've created aviation-grade electric motors with class-leading torque and power. We're looking to partner with the Department of Energy to fund domestic manufacturing of key components of electric aviation right here in the USA. At Joby, we're ready to lead the way in this critical new industry, and the government support can assure the U.S. remains a global leader in zero-emissions electric aviation.
Hello, I'm Bill Ovan, Chief Marketing Officer of Navitas Systems. The mission of Navitas Systems is to make tough batteries for demanding applications in both defense and industrial applications. We figured if we could make a battery tough enough to survive the rigors of a tank, we can make a lithium battery tough enough for the largest commercial battery market outside of car batteries, which is the forklift battery market. And we make advanced batteries for every battle domain, from under sea to vehicles to soldiers to aircraft and all the way into space. As you can see from some of the product pictures, we can't show you most of them, however, given confidentiality. They come in a variety of shapes, sizes, voltages, and chemistries, which are optimized for each demanding application. For approaching 10 years, we've been fortunate enough to have been awarded contracts by both the Department of Energy as well as other service branches like the DoD, NASA, and DOT. We are researching advanced and beyond lithium battery chemistries like silicon anode and lithium sulfur. We're also developing manufacturing technologies in such areas as dry process electrodes to reduce the use of VOCs in making electrodes currently, as well as techniques to dramatically reduce the current drying time of electrodes. In conclusion, we applaud the DOE for its recent notice of intent to provide grants for advanced battery manufacturing. One issue for us, though, as a mid-sized battery company, is that the bar seems to be set very high for minimum grants and associated cost share sizes of 50 million to 100 million. This will keep companies like ours from getting the needed funding to grow our company. And as well known, the majority of innovation and job growth come from small companies, and we therefore believe that adjustments should be considered by the DOE regarding these minimum grants and cost share amounts. We are shovel ready. We just have a smaller shovel, but we can work fast and we can work smart. We laud the Federal Consortium for Advanced Batteries for being formed, as many U.S. agencies, chief among them the DoD and the DOE, have a vital stake in supporting the growth of the advanced battery supply chain in the U.S. As you can see from our presentation, we serve both commercial and government military markets. We therefore believe that funding decisions from the DOE should also consider applicability to the DoD, thus fulfilling the aspirations of FCAB to leverage mutual DoD and DOE investments in advanced battery companies. And finally, we believe that commercial markets like the forklift market, which is, as I mentioned, the largest battery market outside of car batteries, should be acknowledged for funding and not strictly considering just automotive and grid battery markets. So I want to thank you very much for your time and attention and appreciate all that you do.
Hello, this is Chris Turner, the CTO for Inventus Power. I'm going to talk about today our area of interest, which is battery pack manufacturing. Inventus Power is the largest independent lithium-ion battery pack manufacturer in the United States. Our headquarters is just outside of Chicago in Woodridge, Illinois. We design and manufacture batteries for a wide range of products and markets that I'll discuss later. Inventus Power develops and manufactures battery packs for a wide range of applications. We service everything from consumer to medical, military, and now larger applications in light electric vehicle up to hundreds of volts and 100 kilowatt hours. We are headquartered just outside of Chicago in Woodridge, Illinois, where we also have manufacturing facility for medical and military applications, as well as our U.S. Engineering Center. We have locations globally with factories located in southern China, Malaysia, Brazil, and Tijuana. We also have two other engineering centers, one located in Guangzhou, China, as well as Doha, Qatar. Lithium-ion has been gaining traction in a wide range of applications, some of them very critical, like our military applications, where it's being used for soldier power on up to military drones and unmanned vehicles. Lithium-ion's also become critical to the medical industry, where it's being used in everything from surgical tools to ventilators, respirators, infusion pumps, a wide range of devices that people may not realize are relying on lithium-ion either as the primary or backup source of power. As mentioned previously, though, one of the fastest growing segments of the market really is in the conversion of internal combustion engine, or ICE, and lead acid to lithium-ion. This covers a wide range of vehicles, low-speed electric vehicles to commercial vehicles, and you'll see some examples listed here. We have seen a severe cell market shortage since the beginning of 2021. This has really impacted a lot of applications and markets, particularly those in medical and military. It also has exposed the overdependency on relatively few key major suppliers. In summary, Inventus would like to recommend the following. We'd like to see the build out of cell and pack manufacturing capacity, not just for EV, but also EV adjacent markets. We believe there's a need for funding to be able to scale up and upgrade and automate new and existing battery pack manufacturing facilities. We'd also like to see the efficiencies that may come from being able to partner with larger automotive OEMs who already have a lot of this competency and scale. Lastly, we think any funding that's prioritized should be for partnerships and consortiums between materials, cell manufacturing, battery pack, and testing and recycling entities. We believe this really provides the best avenue to success for future growth in the U.S. Information for reference. Thank you for your attention.
Thank you very much, and many thanks to the companies and their insights. Truly appreciate sharing the information in this public discussion. Let us now move to area of interest 11. This is on commercial scale battery recycling and processing facilities. We're gonna learn from 6 companies on topics related to recovery of critical materials from scraps and spent batteries, secondary use, shredding technologies, and second life solutions for end-of-life lithium-ion batteries, logistics, and so on. So with that, let's us move to the video slide deck.
Dear United States Department of Energy, I'm Emil Nussbaum and I represent the Automotive Recyclers Association. Since 1943, the Automotive Recyclers Association has represented professional automotive recyclers. Professional automotive recycling facilities play an important role in the vehicle repair market by providing vehicle owners with cost-effective alternatives to more expensive new original equipment manufacturer replacement parts. Professional automotive recyclers supply recycled original equipment motor vehicle replacement parts to consumers around the world. In addition to the critical role professional automotive recyclers play in the automotive supply chain and replacement parts market, professional automotive recyclers play a valuable role in the efficient, environmentally friendly recycling of end-of-life vehicles. Professional automotive recyclers are the largest collective owners of end-of-life vehicles and are subsequently the largest generator of source material for scrap metal recyclers. Automotive recycling preserves natural resources, reduces the demand for scarce landfill space, and plays an important role in reducing air and water pollution. Automotive recyclers are already the largest collective owners of end-of-life internal combustion engine vehicles and are the primary facilitator for their reuse and recycling. Therefore, automotive recyclers will become a key party within the electric vehicle and lithium-ion battery life cycle and will be a primary facilitator for their reuse, repurposing, and recycling. According to the Argonne National Laboratory, between 10 to 15 million end-of-life vehicles are retired from service each year and enter the domestic recycling infrastructure. Out of the 10 to 15 million end-of-life vehicles retired each year, a substantial majority of those vehicles go to automotive recyclers. As an industry, automotive recyclers will be the main facilitator and sorting mechanism for end-of-life vehicle batteries to be reused, repurposed, and recycled. Automotive recyclers will need to be able to evaluate the state of health of battery units and will need to develop the certification and skills necessary to safely handle end-of-life vehicle batteries. The most popular challenges identified by automotive recyclers when handling end-of-life vehicle batteries are safe handling and removal, knowing what tools and PPE will be required, how to pack and store them, how to get paid for EV batteries suitable for reuse, and how to pay for proper recycling. To address these challenges, ARA has been actively developing training and resources for automotive recyclers. For over 20 years, the Automotive Recyclers Association has worked on providing certification and training to the auto recycling industry through its Certified Automotive Recycler program. In the absence of a formalized training program provided by vehicle manufacturers, the Automotive Recyclers Association has endeavored to collect safety information to create a training program that is freely accessible to all automotive recyclers. ARA and its certification committee has been helping automotive recyclers learn more about processing electric vehicles through the publication of training modules in an electric and hybrid vehicle training technology guide. The U.S. Department of Energy can help ensure that automotive recyclers can help facilitate the reuse, repurposing, and recycling of end-of-life vehicle batteries by assisting ARA in its work to develop training programs and resources for automotive recyclers handling electric vehicles at their end of life.
Global Battery Solutions is a battery lifecycle management service provider. Our role is to assist our customers with 1, fully utilizing the energy and materials that go into batteries initially, keeping them safe in vehicle as long as possible. Secondly, building safe and efficient second use opportunities for batteries after vehicle use, including energy storage systems for decarbonizing the utility grid and supporting its resilience as electric vehicle charging needs continue to increase. And thirdly, identifying end-of-life cells, discharging their energy to the utility grid and getting those assets to high material recovery rate domestic recyclers. Our job is to endeavor each day to build a robust and resilient reverse supply chain for batteries. Global Battery Solution is a battery innovation laboratory with IP and patents in wireless vehicle charging and a technology for battery monitoring, tracking, and integration with control systems, performing R&D and developing technology-driven solutions to support our core battery lifecycle management work, as well as the work of other key stakeholders in this industry. As an operator in the reverse supply chain, providing critical support in logistics, storage, and warehousing, Global Battery Solution is very aware of industry pain points and accelerating costs that threaten to impede the current trajectory. We recognize the strategic security imperative to ensure that automation, 4.0 industry, and advanced manufacturing are used to move batteries efficiently and safely throughout their life cycle, keeping cells in the United States so we retain precious materials for new battery manufacturing potential. Global Battery Solutions invests heavily in workforce development initiatives with local public schools, community colleges, and universities. Additionally, we are engaged with underserved communities in our region, providing retooling and training, upskilling for adults who want to participate in this exciting growth industry. But we must move quickly and strategically to ensure that new-collar job development opportunities are accessible by all Americans and that no communities are left behind.
I'm Bob Mulaney. I'm the CEO of ITAP. The key to the battery industry is extending its life as long as you can and putting them in second life applications to live out their life cycle.
This is Marshall Neipert, Chief Technology Officer of IT Asset Partners. After investing $12 million into R&D, we have successfully built second life solutions for all lithium batteries in the United States. At ITAP, we use the past to power our future.
Lithium batteries can last 10 to 20 years depending on how they're used, but most are discarded within 5 to 7 years. These two mugs represent lithium-ion batteries. This mug represents the scrap recycling solution, and this mug represents reuse. This still has value. Now let's look at the scrap recycling solution. Do you see the difference? And if this is LFP, the taxpayer has to pay to get rid of it.
Everybody knows the tsunami of EVs is coming to America. The question is, what are we going to do with the batteries?
Electronic waste in our landfills is responsible for 70% of the heavy metals leaching into our water table. Only 17% of e-waste is recycled in America today. But what if there was a better answer? What if there was an innovative solution that could benefit everyone? What if we could retain the value of the lithium batteries? Reduce, reuse, recycle. We are all told this as children, but where's the reuse in America? In 2017, ITAP realized that EV batteries would become the largest single volume of low-value hazardous e-waste in the United States. ITAP is actively paying our customers for lithium batteries, including LFP, while processing all EV battery waste domestically and maintaining a zero landfill policy. We are requesting support to expand these second life solutions nationwide and automate the process to create true sustainability for EV battery waste within the United States. Reuse makes things affordable. It provides abundance in a world of scarcity.
All our products are returned here, made here, and moved out into the market as US-made products.
The choice is ours. We can incentivize recyclers to reuse or fund a doomed scrap recycling system.
So the message I have for you, the DOE, is if you want to put the time and effort, we're your partner. We've invested in the technology, we understand it, and we know how to do it safely.
As you decide how to allocate this funding, we hope you consider reuse as the true sustainable solution, turning our country's lemons into lemonade. Thank you for your time.
Hi, my name is Jonathan Dwan with Nuvant Systems, an A3 global company, and I'm here to share a little bit about battery lifetime cycling. Over the past 7 years, Nuvant Systems has been a leader in battery reconditioning technology, and our equipment can be found in shops and businesses worldwide. Since 2015, our EVC battery cyclers have processed over 25,000 hybrid battery packs. Our system increases nickel metal hydride battery lifespan and balances the battery packs, allowing them to be put back into hybrid vehicles for additional years of use. We're currently focused on expanding into lithium-ion batteries and electric vehicles. This effort continues at our facilities in Crown Point, Indiana, Boston, Massachusetts, and Phoenixville, Pennsylvania. To adapt our current hybrid battery remanufacturing for electric vehicles, we must address battery life cycles for environmental, supply chain, and full value utilization. Based on the performance evaluation, the batteries will be designated for extended use in vehicle or second life applications, such as solar panel energy storage. This will divert the hazardous remains from landfills and destructive recycling. The first challenge is developing proper equipment and cycling protocols that are safe for lithium-ion batteries. We know that lithium-ion processing is more dangerous than nickel monohydride processing due to the flammable electrolyte. We need to institute proper safety precautions not only for the remanufacturing process, but also for their use in the extended and second life applications. Another challenge is the fact that there are many different types of lithium-ion chemistries used, as well as many different battery formats and specifications. Here I've highlighted the top 5 battery chemistries on the market, and you can see that lithium manganese oxide and lithium iron phosphate make up the largest percentage. To properly address this, we would need to create a full library of various lithium-ion chemistries and of all the battery formats on the market. Thank you. Please visit us at www.nuvon.com and www.a3global.com, and my contact information is below.
Hi, I'm Kunal Falford, the Chief Strategy Officer here at Li-Cycle. We're a lithium-ion battery resource recovery company listed on the NYSE. Our main goal here is to recover critical materials from spent lithium-ion batteries or manufacturing scrap to close the loop in the lithium-ion battery supply chain, and do that domestically or locally to support onshoring of a supply chain. How are we doing that is really through 2 core pieces of technology, what we call our spoke, which shreds any of those types of materials from manufacturing scrap through full EV packs into intermediate materials, and our hub, which then refines some of those critical materials into battery grade products such as lithium carbonate, cobalt sulfate, nickel sulfate. And how are we deploying our assets? Well, we have 2 existing assets built in 2020, one in Kingston, Ontario, one in Rochester, New York, both of our spoke facility. We are 3 spokes under development in North America, or in the US actually, in Arizona, Alabama, and Ohio, the last of which will be directly on the Ultium Cell site to manage their scrap and recover intermediate products on site, thus benefiting from savings in logistics and packaging. We're also building our first commercial hub in Rochester, New York. That'll be operational in 2023 and will be able to produce those critical materials in large scale. What do we need and what have we learned over this time? I guess a couple factors that will continue to develop or evolve, one being permitting, and streamlining that, as each state we've seen has different process, different timelines, but this industry is moving quickly, electrification is moving quickly, and particularly spoke deployment needs to move quickly as well. Additionally, workforce development is an important factor. We have a diverse workforce from operational staff through engineer, process engineers, chemical engineers to operate the hub. And having access to those employees in different regions of the country will be an important factor moving forward. So just to conclude, high level, Li-Cycle has a scalable technology, economically sustainable through the high recovery rates, and environmentally sustainable with a low footprint relative to critical materials coming from primary resources. I'd like to thank you for your time and look forward to continued discussion.
Hello, I'm Tom Schaefer. I'm Ecobat's Vice President for North American Lithium. Ecobat is the world's largest lead-acid battery recycler. We're headquartered in Irving, Texas, and we have operations throughout the United States, as well as in Europe and in South Africa. Today, we're working on scaling our lithium business, both here in the US and in Europe. In Irving, Texas, we have a pilot plant that is demonstrating for R&D purposes all processes of lithium battery recycling from battery input and diagnostics all the way through to black mass production. In Europe, we have commercial operations which are capable of diagnostic sorting all the way through shredding and black mass output. EcoBat's goal for the United States is to have a commercially viable facility up and running by the end of 2022. There are several challenges that we face as we approach this goal. The first challenge I'll discuss is the regulatory environment. Dynamic regulations can be cumbersome and add additional risk to companies looking to scale operations such as EcoBat. While health, safety, and environmental stewardship are at the core of EcoBat's business, there must be a fair balance with the freedom to operate profitably in an open forum for regulatory feedback. Second, the large-scale machines required to shred and refine the battery materials are relatively scarce and have been severely impacted by the supply chain issues of the last 2 years. Capital requirements are increasing, which is rebalancing the economics of such an operation. Last, but certainly not least, the challenges of the labor environment are certainly impacting our business. Top-notch EHS is one of our core principles, and lithium batteries present a number of unique and very difficult challenges. Personnel retention is required in order to maintain a top-notch safety environment. Between 30 and 100 operators are required per plant, plus additional office and back office members of personnel and administration. Each person requires several hours of training as well as additional recurring training to keep that safety record top-notch. Improper
Okay, with that, thank you very much to all the companies. It's exciting and great to see the several solutions, the paths for battery recycling. Dave Howell reminded all of us yesterday that less than 5% of lithium-ion batteries are recycled today, so significant work and headways are ahead of us. And with that, it was a pleasure being with you all, and I hand it over to Venkat. Venkat?
Thank you so much, Ilias. Deeply appreciated. So we have a few more things left in this program, especially a big AOI coming up next, and we have a break before that. But before we go to the break, there are two things I want to do. First, you've seen a few of our faces. We've given presentations, told you things from Argonne, from NREL, from Oak Ridge, and you're going to hear more from PNNL. But there is a team of people behind all of this that makes events like this happen. I'll be honest with you, I do nothing. It's actually, people have heard me say this, that it's really the sort of the background of people who've worked very hard for the last 3 weeks. 4 weeks ago, we did not have an event planned. Today, we have an event. It's been going on for the last 2 days. And you can see the list of people here. I won't read their names, but it covers everything from people in the events team at Argonne, the audiovisual team, people who work on technical content, who've looked at all of your videos and arranged them in different places, the communication team and the digital team, and a team for coordination. But I also want to call out our DOE colleagues who've kind of met with us, I think, every other day, sometimes every day, just to tell us what's going on, give us some input on in terms of how this agenda should be organized. So I want to take a second to make sure that we acknowledge all the people there. Hopefully you all can give a virtual thank you to all these people that you see on the slide, because without them, it's pretty much impossible to create a meeting like this, especially in the time it takes. I've come to the conclusion that online meetings take 3 times as long as in-person meetings, just because of the amount of logistics involved. And so thank you to this team for doing that. So I appreciate it. We are now going to go to a little bit of an interactive session involving polling. So you can go to this website. Turns out I recommend that you go on the website. I see a few people. You can see it on the link in the chat. Click on that link. You will immediately get to it. If you're in a phone, I advise you to get to a browser and click on this link. It's pollev.com/argonne1. pollev.com/argonne1. There is also a way to do text messaging. I highly don't recommend it. Do not text message. Please use a browser. So let us now go to a few polling questions to get some input from all of you. The first thing we're going to ask you to do, actually, I was kind of thinking we should go to question 11 if you can, Betony. Thank you. I appreciate it. So what we're going to do is, this is called a ranking question. So if you go to the website, what you're going to see is a question that says, tell us what are the challenges stop you from expanding production domestically. So what you do is you hover your mouse on the answer, and then you will see an up and down arrow. So please use the up arrow to push the ones that you think on top, and then you can push the ones that you think can be in the bottom down to the down arrow. Again, the idea is to go to this website, pollev.com/argon1, and then you will see the poll and start to click on things. So I'm going to give it a few seconds, maybe in the order of 30 seconds, so that people have a chance to log into the website, have a chance to take a look at the poll itself. Ranking polls take a second. Again, hover your mouse and move it up or down, depending upon your interest. You already see some interesting changes there. Skilled workforce is showing up, something that we were hearing about quite a bit yesterday also. We're seeing permitting delays, another thing that is of importance. Interesting lack of access to finance. Yesterday, I noticed that was actually pretty, I shouldn't say low on the list, but it was lower on the list. Today, it seems to have come up. I wonder if some of this is just the nature of how much it costs to build factories as you go from upstream to midstream. Interesting, nonetheless. So let's give it another 15 seconds or so for this question, just so that we get people to answer, and then we will move after that. I don't see many changes, so I'm going to call it and say it looks like we've seen the top three here: workforce, finance, and a lack of access to suppliers as being big challenges for this particular community that we had today. Let's now go to the next question, question 12. This is an open-ended question. What we're asking you is, what is the single most important thing the US government can do to make it possible for US companies to compete against these global dominant players? 5 words or less, guys, so be very succinct, not as succinct as just typing the word P, but you may want to have a word there instead of a letter. But the regulation is fantastic. That we've heard that before as being a big challenge. Funding, we heard that yesterday also. Keep it coming. This is a way for you to communicate what you think are the biggest issues, so that people in the federal side or in the audience can learn from you as to what you're struggling with. I see John put investment in the chat. Thank you, John. But if you can get to the polling window so that we can collect this information, and it's all collected in the same spot. Domestic education and training, very important. So that's another topic that I think has come up before. So keep it coming. I think there are some good things coming out here. Large CapEx investments, partnership demonstration, grants and IP protection. Yeah, by America Made, it says. Yeah, that's an interesting one to sort of think about, I think. Work with ODMs, dollars. Yep, funding has always been a concern, I think. I will say the one good news is that, I said this yesterday, 10 years ago, I used to live in Silicon Valley at the time, or close to Silicon Valley. Everybody was complaining about lack of access to capital. That certainly has changed in the last 2 years, but I'm still seeing a lot of people talk about funding. It's an interesting difference between yesterday and today, I will say, in terms of how much that's showing up. Again, a reflection of maybe where people are in the supply chain itself. I'm going to let this go for another 5 seconds or so, and then we should jump to the next question, I think, in the interest of time. Chemistry is beyond NMC. Patterns. This is great, guys. This is fantastic input. Again, this is going to be extremely useful for all of us in LiveBridge and in the federal government to understand where people believe we have bottlenecks. Why don't we let this go for, why don't we go to the, why don't we go to the next question? I think this is fantastic. I think we're seeing some repeating themes, so it's great for us to go there. Now we're going to ask you, again, a ranking question. Where do you see the biggest skill gap so that you could build out your production, domestic battery supply chain? Again, this is a ranking order question, so you have to click on the right one and you got to sort of move it to the right spot. So take a second, do it. It's going to take you in the order of 30 seconds to get the answer done. So please.
Actually, Venkat, this one is multiple choice.
Oh, I'm sorry. This is a multiple choice question. So you don't have to do that. You can just click on the ones that you want. So thank you. All right, we are seeing a few things showing up. We're seeing process engineers, which is an important one. We're seeing higher ed graduates, plant operates technicians. It's interesting that we're seeing process engineers as one of the biggest needs that we have. I think we didn't ask this question yesterday. I see John saying C and D, process engineers and higher education. on-job training. So this is really sort of looking like, there is a clear thing where we're catching this thing. We didn't ask this question yesterday. We couldn't get to it. We had other poll questions that we're going through. So this is interesting to see that at least as we go to the mid and downstream part of the supply chain, a clear need appears to be process engineers. Obviously, there are needs that are beyond that when it comes to the operators and the technicians. So this is great. We thank you for that. Let's go to the next question, if you will. Bethany, I think we can go to the next question. Thank you. So this is again, an open-ended question. What we're asking you in 2 sentences, so keep it short, please. What policies do you think we need to ensure we have a skilled domestic workforce? So for example, do you feel like if there is a way to get fast track accreditation of new vocational courses that can help you, can you think of things that you believe can be extremely useful for us to kind of move towards a place where we can help you guys find those process engineers or the rest of the stuff that you were writing out in the previous poll question? So upgrading educational courses, very important, yeah. That's such fantastic tuition support for relevant STEM education. We heard one of the things that came up in one of the videos we were watching was getting STEM in the, so even in the grade school level, which is really fantastic. Collaboration with pioneering universities. Obviously, grade schools only feed the pipeline 10 years from now. I have a son in elementary school, so more interest in elementary and middle school. Under co-op programs, that's great. Yeah, that's come up before. How do you get co-ops? That can be a great way to do it. Lax visa requirements. Battery technician training, yep. Community colleges have come up quite a bit, I think, in various forums where education questions have been posed before. So this is great to see that that question has come up quite a bit. Keep it coming. This is very good information, guys. I mean, we're going to have a panel after this where we're going to talk a little bit about education, workforce, but also other questions related to that. So it's very good to see that we're having all this input coming from all of you. Community college evening classes, STEM education, electrochemistry education. This is a topic that has come up quite a bit in the, certainly in the sort of the PhD, master's level workforce. Support internships, yep, strong collaboration with industry and academia. Yeah, no pie in the sky research. That's an interesting word there. Vibrant local industry. Yep. Visas has come up a couple of times. All right, so this is great. I think we're seeing some repeating themes, training at national labs. I mean, certainly, I think all the national labs are very interested in something like that. We are at 3:14. So I'm going to suggest that we actually stop with this. This has been fantastic input. These polls have been great for us to get some feedback. I'm going to suggest that we go on a break. I'm going to suggest that we keep the break at, I'm going to say 8 to 10 minutes. And I'm going to see if somebody from the Argonne team, Betony or somebody has to correct me. I apologize. I'm not able to keep track of the chats that are going on in parallel to this particular session. So Betony, when are we coming back from break?
We will come back in 10 minutes. So at
3:25 Central Time, which is 4:25 Eastern Time. Is that correct?
That's correct. I was doing the Eastern and Central Time in my head. Yep, that is correct.
All right, folks, 10 minutes. We'll be back at 4:25 Eastern Time. And then after the break, what we're going to do is we're going to see AOI 12. So my colleague from Pacific Northwest National Lab, Jun Liu, who actually runs a big consortium there called the Battery Family Consortium, is going to be the moderator, and he will walk us through this topic, which is on domestic cell manufacturing component, sort of the next generation things like silicon and solid state, and looking at novel manufacturing methods. So come back in 10 minutes. There's a long session there, which some interesting companies that are going to be showing us their technology, but also the challenges they face in US manufacturing. Thanks, folks.
get a shiver in the dark. It's raining in the park, but meantime, south of the river, you stop and you hold everything. A band is blowing Dixie, double fall time. You feel alright when you hear the music ring. Well, now you step inside, but you don't see too many faces. Coming in out of the rain, they hear the jazz go down. Competition in other places, but the horns, they blowing that sound. Way on down south, way on down south, London town. You check out Guitar George, he knows all the chords.
All right, we're good.
Mine is strictly rhythm, he doesn't want to make it cry or sing. If any old guitar is all he can afford, when he gets up under the lights to play his thing. And Harry doesn't mind if he doesn't make the scene.
You know, folks were loving the music, but I want to see if Jun is back on, and I think he is.
I'm back here, and somebody need to start the video.
You may need to open your.
I can. Let's see if I can. I cannot.
We can see you,
now,
Jun.
okay, now it's working. Should we start?
Yes, sir, absolutely. Please.
All right, welcome back. It has been a long day, but we are making great progress. My name is Jun Liu from Pacific Northwest National Laboratory. I'm also a joint professor at the University of Washington. As Venkat said, currently I serve as the director of Battery 500 Consortium, which is a very important program funded by the VTO office. This program is unique. It includes many national labs and universities and industry to develop next generation batteries beyond lithium-ion batteries. I think the philosophy is kind of similar to what we are trying to do here. In this program, we try to cover not only discovery, manufacturing material, processing of materials, fundamental science, but we also worry about cell design, manufacturing, optimization, testing, validation, scaling up, all the issues that will position the United States for strong leadership position in the future. So in AOI 12, we have heard so far a lot of talks on or video presentations on lithium-ion batteries, components manufacturing. Some begin to touch on emerging new battery chemistry, next generation battery chemistry, novel manufacturing process. That's really, hopefully in the next session, we have many companies, 1 hour long video presentations would really have a little bit more emphasis on the new technologies and the manufacturing process. This is very important for the United States in 2 ways. One, US is still the innovation engine for science and technology. New battery technologies and manufacturing process would certainly place US in the leadership position. Another thing is if we go beyond just lithium-ion batteries, that we have a chance to really to create a brand new supply chain that's independent of the critical materials. So this is very important. Hopefully we'll hear much more about this in the next 1 hour or so. With that, let's start the video.
Hi, I'm Adam Briggs, and I'm with Ambry Inc. Ambry is bringing forward liquid metal batteries for stationary large-scale energy storage systems and data centers. This technology is a 4-hour to 24-hour duration system, and it has a lower cost versus lithium-ion for these applications. It also has a 20-year lifespan with minimal degradation over that period. It has strong safety features in that the chemistry does not generate any gas. There's no thermal runaway. There are no flammable materials inside these containers. And the materials are unique. It's a calcium antimony chemistry. So therefore, we're not competing with EVs or other high volume applications for those materials. It's a US invented technology, mainly at MIT and at Ambry, which is based outside of Boston. And we do plan to manufacture these cells and containers in our initial US manufacturing facility. Cells are packaged into trays. Trays are packaged into containers. The containers are about a megawatt hour each, 250 kilowatts of power capability. It's a high temperature chemistry, which means it does not require air conditioning systems. It's very suitable for hot temperature locations or very cold temperature locations. Ambry really sharing this technology in order to get on the radar with DOE. We have developed this technology in the United States. We're planning to manufacture it here in the US. We're opening our first manufacturing facility later this year in Massachusetts. And then in the end of 2022, we'll be securing a site for a high volume manufacturing facility somewhere else in the United States. We'd like to work with DOE on setting up those manufacturing facilities and understanding that there are non-lithium technologies coming that will be suitable for helping the proliferation of renewable energy onto the US grid. Thanks for your time.
Pure Lithium is commercializing a breakthrough lithium metal battery technology and manufacturing process that is clean, sustainable, scalable, and cost-effective. Lithium metal is widely acknowledged as the material needed for superior next-generation batteries that are safer and higher energy density. Pure Lithium's novel technology eliminates more than 80% of the current manufacturing costs in lithium metal production, which in turn unlocks widespread adoption of lithium metal batteries that cost less than $50 per kilowatt hour. The United States is home to a diverse range of lithium-bearing deposits, from hard rock spodumene and oil field brines in the southeast to clays, conventional brines, and geothermal brines in the west. Pure Lithium's technology can take that lithium from the ground and put it into a battery right here in the US, leapfrogging the current Asia-dominated supply chain. Pure Lithium's metal electrodes are elementally pure. Our one-step electrodeposition process creates a clean, native interface that's protected from air and moisture, which improves performance and reduces costs. As a woman-owned business, Pure Lithium has embedded working for environmental justice and treating communities as stakeholders into the very fiber of our company. We are uniquely capable of training technicians with high school or technical backgrounds to hold valuable jobs in the battery industry. Pure Lithium's process can be deployed either close to lithium production or in manufacturing hubs. We are an integral part of securing the energy supply chain, and that depends on building the lithium batteries of the future here in the United States.
Hi, my name is Maciej Jastrzębski, and I'm the CEO and co-founder of Align Metal.
And my name is Dean Frankel. I'm the Chief Commercial Officer at Align Metal.
So at Align Metal, we're focused on developing and commercializing technologies for next generation batteries. We're working on technologies both for lithium anode, metallic lithium anode battery components, and the lithium metal that's required to produce them. Ultimately, once commercialized, these technologies will enable cheaper, safer, and more environmentally friendly electric vehicles.
The first technology that we're developing is a lithium metal anode. We make these lithium metal anodes in our Rochester pilot facility that allows us to be both cheaper and better performing than the existing top-down manufacturing process that consists of extrusion and then rolling. Why are we cheaper and better? Because we start with basically zero and build up. So we are a bottom-up process. We use physical vapor deposition to put the lithium down onto a moving substrate in a roll-to-roll manufacturing environment. And we are planning on scaling this production technology to a commercial demonstration facility in 2023 in the US. We believe that that facility and this technology is not only applicable for metallic lithium anodes for next generation batteries and e-mobility, but also in silicon dominant anodes where pre-lithiation is required.
Our second technology allows us to produce metallic lithium from lithium carbonate. Now, lithium carbonate is already widely used in the lithium-ion battery industry. And by using lithium carbonate, and unlike the incumbent process, we are able to eliminate chlorine gas emissions from the metal production process. This is both more environmentally sound and ultimately requires less equipment, allowing us to produce the metal at a lower capital intensity and at a lower operating cost.
When you combine these two technologies together, Limetal offers a cheaper, better, and cleaner solution for both lithium metal and metallic lithium anodes. These are industries as an example, with the removal of lithium chloride from metal to lithium carbonate, we believe that there is an environmental advantage and ultimately a permitting advantage for the metal production technology. Moving on to the lithium metal anode, we believe that there's a significant amount of workforce development in areas like roll-to-roll processing. For example, in Rochester, New York, where Kodak has largely shut down operations, there is a tremendous amount of films and roll-to-roll processing experience, and we hope to build on that with these two commercial demonstrations. We thank you for your time and look forward to the opportunity.
Hello, I'm Michael Canada, the Chief Manufacturing Officer at Scion Power. Scion Power, building the future of batteries now. Scion Power is an advanced lithium metal anode technology company with world-class facilities and capabilities. Headquartered in Tucson, Arizona, we currently occupy 2 facilities with full-scale battery research and development and manufacturing capabilities consisting of state-of-the-art cathode coating manufacturing, proprietary protective lithium metal anode manufacturing, and large format metallic lithium cell manufacturing located in our 100,000 square foot facility. Our world-class test facility is equipped with over 2,000 channels for cell testing and formation, as well as a suite of industry-standard battery testing capabilities. Today, Scion currently holds more than 470 international patents and patent applications. Launching our next-generation Lycerium battery technology, we are engaging in development activities with commercial partners and are finalizing our manufacturing expansion plans for the future. We've distilled our expansion initiatives into 3 phases. Phase 1, in an effort to meet current demand, we will launch our new pilot facility that will be co-located on our campus, delivering large format commercial cells of 50 to 75 amp hours. Phase 2, we will expand our manufacturing footprint, entering the gigafactory class to meet forecasted demand. And as we anticipate continued growth in the EV space and continued market pull for advanced battery technologies, we expect to continue manufacturing expansion efforts to align and meet future demands as our Phase 3 activity. Some of the challenges U.S. battery manufacturers face are common to other industries today, with the first challenge being critical supply chain constraints. This would include availability and sourcing of raw materials, as well as critical component and material availability with equipment vendors. Second, the availability of existing or idle lithium-ion manufacturing facilities that could be retrofit and upgraded with next-generation technology is limited. And third, the capital requirements needed to build and commission battery manufacturing facilities is substantial. Having access to capital and continuity of supply will be vital. Building the bridge for the next generation workforce is essential. As we've entered this new era of electrification and advanced manufacturing, we must focus on the training, development, and recruitment for a variety of disciplines and skill sets. It is imperative that we consider the entire ecosystem, securing public-private partnerships, working hand in hand with educational institutions to build training programs to develop the next workforce is essential. The electrification movement is no longer a question of if or when. The electrification movement is now.
II-VI Incorporated, a Pennsylvania-headquartered leader in engineered materials for more than 50 years, is bringing to market breakthrough technologies to enable the sustainable and cost-effective electrification of the U.S. economy. These include advanced battery materials, proprietary lithium-sulfur batteries, and high-efficiency hydrometallurgical recycling of battery waste. Inspired by work led by Khalil Amin at Argonne National Lab, the engineered material behind II-VI's breakthrough lithium-sulfur batteries is a patented electrophilic carbon skeleton, which chemically binds to sulfur to prevent shuttling loss of the active material. Solving this shuttling issue enables the highest reported energy and cycling performance for lithium-sulfur battery cells. Based on abundant sulfur, these cells contain no cobalt or nickel and can be further optimized for high power performance by adding highly conductive selenium to the carbon-sulfur cathode. To ensure a competitive and stable supply chain for this breakthrough chemistry, II-VI has invested in pilot-scale manufacturing of lithium-sulfur battery materials, electrolytes, and electrodes, and will make these available to cell manufacturers at commercial scale. Completing the whole life cycle approach, II-VI is also at the forefront of hydrometallurgical recycling of battery materials, with processes proven to extract more than 90% of the critical metals value in battery waste streams. This can be applied both to recovery of value from manufacturing scrap and end-of-life batteries. With these initiatives, II-VI is positioned to accelerate electrification of the U.S. economy, enabling next-generation battery chemistries, efficient recycling, and a stable battery material supply chain. Lithium-sulfur cells are expected to enter pilot production in 2024, with battery components and materials available beginning 2023, while pilot-scale recycling will begin in 2025. Challenges to making these activities competitive globally are the need for skilled electrochemical and hydrometallurgical manufacturing personnel, simplified transportation logistics for batteries and battery materials, and support from local, state, and federal governments for the large capital investments required to operate at efficient scale. II-VI Incorporated, whole battery life cycle solutions, enabled by materials that matter.
We're going to continue. We have two more groups to go through. So we're going to continue our video presentation from Applied Materials and other companies. Go ahead.
Hi, I'm Jim Cushing, General Manager of Energy Storage Solutions at Applied Materials. It's my pleasure to speak with you today about how the government and industry can work together to establish global leadership in lithium-ion battery manufacturing. Doing so can create millions of jobs and economic activity. Additionally, through advances in battery technology, we can help fight climate change and drive environmental justice by accelerating the adoption of energy storage in two of the largest greenhouse gas emission industries, power generation and transportation. Applied Materials is the largest supplier of high-volume manufacturing equipment for leading innovation industries such as semiconductor and display. We're leveraging some of those innovations to develop advanced lithium-ion battery technology and then scale it to gigawatt-level production. When we look at where the U.S. is in this industry, we have great potential. We have the world's best universities, the strongest national labs, the leading EV company, and tremendous pipeline of startups, many of them very well funded. But we are losing the battle when it comes to manufacturing and the economic leverage that comes with the surrounding supply chain. So how can we take advantage of our innovation strengths to gain global leadership? In the 80s, the U.S. formed a consortium for the semiconductor industry called Semitech. The consortium created a technology-driven roadmap, which is still followed today. It brought the supply chain together to rapidly develop and release new, better technology. We recommend doing something similar today. Step 1, bring together the consortium. This is a pre-competitive partnership between industry, national labs, DoD, and the universities to establish a technology and cost-driven roadmap. Second, we need to create a physical space for the supply chain to work together with the specific aim of accelerating the development and manufacturing implementation of this advanced technology. Third, and this is going one step beyond where Semitech took it, we need to establish a gigawatt-scale pilot manufacturing facility to prove out both the technical performance and long-term cost potential of these innovations. Last, once we've proven the advanced technology and the cost viability, we can then build gigawatt-scale factories in targeted regions across the U.S. and even globally. Thank you very much for your time today.
Hello, my name is Chad Schaefer, and I'm the director of our digital enterprise team at Siemens Digital Industry Software. I also sit on the board of NADBAT, which is the National Alliance for Advanced Transportation Batteries, a trade association focused on the development and commercialization of advanced battery technologies in North America. Siemens USA has been a national asset moving America forward for more than 160 years, investing $40 billion in the United States over the past 2 decades, and represented by 40,000 U.S. employees. Siemens supports critical infrastructure and vital industries as a technology partner that forms the backbone of America's economy. This includes supporting the battery industry through electrification, automation, and digitalization. Digitalization in particular provides a platform to simulate through the use of digital twin techniques. This is an opportunity to practice and test new ideas virtually versus trial and error in the real world. This can save considerable time and resources. We also have had the opportunity to engage with U.S. national labs and U.S. manufacturing institutes such as MXD in Chicago and LIFT in Detroit. These environments play a role in accelerating innovation. Siemens is actively working with companies along the battery supply chain, from upstream providers of material to machine builders, battery manufacturers, those that consume batteries, and ultimately the importance of recycling. The entire value chain ecosystem matters when it comes to battery. Siemens is also building out U.S. electric vehicle charging infrastructure of the future. We are currently committed to building 1 million EV chargers for the U.S. market by 2025. So when it comes to expanding U.S. capabilities in advanced battery manufacturing, from my perspective, there are 2 main areas of focus. First, we must support domestic machine builders that make battery producing equipment. Helping those that make the machines themselves, which produce both lithium and solid-state batteries, localizes our ability to produce. Today, there is a long wait for companies outside of the U.S. to deliver battery-making equipment. There is also the opportunity to innovate with machines that increase yield and reduce scrap. Second, it's crucial that domestic battery startups can compete at scale. However, a gigafactory is capital intensive. We can support innovative battery companies emerging to create healthy competition. We see that cutting-edge digitalization techniques combined with agility can improve domestic supply of batteries. This will help ensure that America has its own domestic source of battery creation. Finally, I would like to thank you for the opportunity to offer my perspective. The advanced battery industry can be the backbone of a clean and resilient energy future in America. I would be happy to address any further questions in the future. Thank you so much for your time.
Hello, my name is Brandon Babe, Senior Director of Sauer Essig's Energy Business. This presentation addresses the topic area for demonstration of domestic battery cell and component manufacturing, including next-gen chemistries and novel manufacturing processes. The presentation today will primarily focus on manufacturing processes, specifically dry electrode manufacturing. Starting with a company overview, Sauer Essig is a division of Matthews International Corporation, headquartered in Pittsburgh, Pennsylvania. Sauer Essig designs and fabricates tooling and purpose-built production lines for industries using high-speed, continuous rotary production. We're a supplier to the clean energy market, both for lithium-ion battery production and hydrogen fuel cell manufacturing. For batteries, we design, engineer, and build electrode calendaring lines, both for traditional wet process and for dry process. This includes lab, pilot, and mass production lines. For hydrogen fuel cell production, we design and fabricate rotary embossing and cutting tools, and have the capability to engineer and build production lines for fuel cell component manufacturing and stack assembly. We have designed and built machines specifically for the production of electrodes using a dry process with no organic solvents. These machines have demonstrated the ability to produce quality electrodes using a dry process. It works by using calendaring systems to produce a web from dry electrode powder, which is then laminated onto a metallic foil. And please note that Sauer Essig does not manufacture batteries or electrodes. What we do is engineer and build the production lines to enable battery manufacturing. We're supporting the domestic production of batteries in a number of ways. Our electrode calendaring and laminating machines are designed in Germany, but we assemble, install, and commission them domestically. We're building roller refurbishing operation to recoat and refinish the rollers that are worn after use on the production line, which helps extend the life of the rollers. We're also investing in a new application development center in the US for battery manufacturers to experiment with formulations and processes on lab and pilot machines, both for the wet and dry process for electrode manufacturing. To boost domestic capability, we have several workforce requirements, including engineers and skilled labor across multiple disciplines. This includes mechanical, electrical, and controls engineers, electrical and mechanical technicians, as well as skilled machinists. Thank you for the time and for the opportunity to share how we're boosting domestic production of batteries.
Hello, my name is Steve Weiss, president of Xylectric. Xylectric is interested in the demonstration of advanced cell formation techniques that include integrated cell grading. Xylectric is located in Fall River, Massachusetts, in a hub zone. Factory automation and quality control are becoming more and more important. Xylectric's innovative test hardware and advanced formation techniques help address known problems facing the EV market today. First, EVs remain expensive. Costs can be reduced by reducing material input or increasing energy density. However, innovative manufacturing technologies has been deemed the most obvious path to continued cost reduction. Second, commercializing batteries is difficult. Cell development is slow, and cell and pack validation also take many years. Finally, there is a high industry-wide recall rate, which is indicative of the challenges commercializing EV packs using the development processes that exist today. New detection modalities to ensure pack safety and active feedback control for lithium-ion and pack manufacturing is required. Xylectric's core technology is a new electrochemical technique called cyclic coulometry. Cyclic coulometry was invented to measure the loss rate or self-discharge rate of a lithium-ion battery in an addressable condition, for example, at a particular temperature, voltage, or current. At the same time, without any added cost or complexity, the technique measures the associated growth in the complex impedance. Xylectric is currently developing derivative QC metrics based on this and other key insights that can be measured in under 60 seconds. Based on these innovations, Xylectric is developing techniques for cell development, cell modeling, pack and cell validation, as well as manufacturing. Xylectric has been developing fast formation techniques based on our unique hardware for the last year and a half. The goal is to show that cell grading can occur at the same time during formation while providing superior insights to the QC metrics used today, such as multi-week OCV holds. Xylectric is interested in leading a response to topic area 12, new manufacturing processes, or partnering for topic area 12 or 6 with appropriate partners who are interested in the new formation techniques. The objectives include faster throughput, improved battery insights, and integrated active feedback systems for smart manufacturing initiatives. The program would develop the hardware, process, and algorithms. Dielectric seeks manufacturing partners from lithium-ion or beyond lithium-ion categories. In particular, emerging chemistries may not require the same formation processes, but would still require innovative and advanced cell grading. If you would like to partner with us or have us partner with your project, please email me at the address below. Thank you very much.
We'd like to introduce you to a new manufacturing platform for injection molded batteries, ultracapacitors, and fuel cell plates. Probably best suited for packs. It's an established manufacturing technology that always delivers products faster and cheaper, and in many cases much better. This is an opportunity for which we have IP, issued and pending, trade secrets, and new injection moldable resin compounds. These products can be molded as individual cells, a cell phone battery, in large multi-cavity, multi-shot molds, or as battery or capacitor packs of say 1,000 cells all at once for EVs. Additionally, the wiring bus can be molded in series or parallel as an integral part with the electrodes, thereby further reducing the labor content. The assembly labor costs are gone. Because they are polymer alloys, they are injected under several thousand psi pressure with heat, fusing and surface blending the entire polymer alloy matrix, making it into one solid mass. The anode, the cathode, the electrolyte, the case are all in one solid molded piece. Separation is inherently less probable. There are no air bubbles, gaps, voids, even under hard field use. Additionally, because of this novel manufacturing approach, new conformal geometric shapes are possible. Like all plastic parts, they can look like just about anything you can imagine. Not just the round cylinders or flat rectangles so common today. It is adaptable to many different chemistries, anything that can take the heat beyond lithium. This is a game changer in terms of cost reductions, taking capital and labor out. Physically more robust electrical storage units, probably higher capacities, new product designs, new applications, and geometric options. If this intrigues you, please connect with us on LinkedIn. And thank you for your time and consideration.
The goal of LiBridge is to bring together all battery industry participants to promote a secure, sustainable battery supply chain and establish American leadership globally. We firmly believe that the best way to accomplish that is through a comprehensive set of open industry standards. The benefit of such standardization are briefly introduced in this slide. The first benefit is to democratize market access to battery suppliers and users, giving each participant in the market appropriate real-time access to the market based on their individual functions and needs within the supply chain. Multiple solution providers for each function of the market ensures flexibility while focusing on each contributor's core competencies and value to the market. Efficiencies in managing the supply chain and distribution of a finite resource is of course critically important in a successful supply chain, as is the ability to rapidly introduce innovations and allow the quick adoption of new technologies as they are developed. The successful supply chain will also include trusted certification of activity, transactions, and assets within the market, and will also allow transparent regulatory oversight and reporting. In order to be successful, an open standard has to be applicable today, in addition to providing a clear path for the future. The standards have to be comprehensive and take into account the entire ecosystem over the full life cycle of batteries, from cell manufacture to primary and secondary life deployments through efficient recycling and end of life. The key requirements of a successful open standard for vehicle batteries begins with being agnostic to cell type and chemistry, allowing optimal granularity for vehicle design freedom, flexibility of use, and captured value. The ability to size vehicle batteries for actual use cases on demand is key, as is the decoupling of vehicle production from the battery supply chain. Full tracking of the battery life cycle, as well as certification for compatibility and compliance to the standard, as is ensuring chain of custody tracking and use control. Based on decades of experience, including designing and building high-performance vehicles from the ground up, Modbat has developed a comprehensive suite of technologies. We are proposing them as the foundation for an open, royalty-free industry standard. We call this standard the Extendable Battery Framework, or EBF. It includes Charge Node, a self-contained intelligent module with internal BMS and isolation, Charge Mesh, a resilient, on-demand configurable power system architecture, as well as secure device-linked digital twin NFTs. Though based on proprietary IP, the Extendable Battery Framework is royalty-free to manufacturers of certified batteries and vehicles and administered by the Safe Battery Alliance, a 501c6 nonprofit.
To build the battery-powered economy of tomorrow, U.S. manufacturers today must navigate a complex supply chain, meet safety standards and regulations, and get to market quickly. UL is the global safety science company. We are a leader in testing, inspection, and certification for large batteries and energy storage systems. We have extensive experience serving the entire battery industry value chain through our vast regulatory knowledge and regional laboratories. Since its founding in Chicago, UL has remained steadfast in pursuing safety on the cutting edge of American innovation. Our expertise has helped develop more than 1,600 standards, including the world's first stationary battery, the first energy storage system, and before the market demanded it, the standard for repurposed batteries, anticipating what eventually became a vital piece of the modern supply chain. We also helped develop the recently published UL 9540A test method. We have more than 500 renewable energy experts with deep knowledge of requirements in more than 150 countries. Of the Fortune 500 and Global 500, more than 60% are our customers. And the U.S. National Renewable Energy Laboratory chose us to be the permanent host for SolarApp. Testing is critical to the entire battery supply chain, from manufacturers who rely on our insights into standards and our third-party impartial testing and certification, especially during component process, cell, and pack manufacturing, to government agencies who rely on our expertise to help develop standards, to consumers who rely on the trust and confidence that comes from third-party testing, inspection, and certification. UL is already planning to build the largest commercial battery laboratory in North America. Our funding will build a laboratory capable of battery testing for passenger and light to medium duty trucks, industrial trucks like forklifts, and stationary batteries for applications such as energy storage, data centers, and telecommunications. However, this laboratory is not designed for the much bigger batteries that power heavy-duty trucks, construction and agricultural equipment, ships such as tugs and ferries, and defense vehicles. With matching grant funds, we can scale up our operation to accommodate these very large battery applications, provide the critical testing that is missing in the marketplace, and add long-term performance testing. U.S. battery independence is critical to maintaining the cutting edge of American innovation, construction, agriculture, shipping, defense. With support from UL, these critical American industries and more can power the country with greater speed, with greater safety, and with greater efficiency through the 21st century.
All right, we are making great progress. We still have 7 companies who will present the company profile and programs in the last group.
Where the U.S. is always led is in innovation and in entrepreneurship, in breakthrough, frankly, in high technology manufacturing.
What we do is we try to translate our knowledge to the customer, and that comes in the form of projects, that comes in the form of education and outreach.
Running short courses and educational series to make sure that students are getting appropriate training in the energy storage industry.
Everyone's kind of scared of the industry. You can't really go to school for batteries. You don't need the technology specifically in batteries as far as training and schooling to flourish in this industry.
While we won't probably be the quantity leader, we can come in as the quality and the innovation leader.
The vehicle to grid system that I'm standing in front of here with the fast chargers, technology has already been proven that this works. It's not only a charging station, but it's also what they call a bidirectional system that allows a push-pull on the V2G network.
This is where the next technology is coming from. Here's how that technology comes about. Here's what it takes to put it together, and then deploying that throughout the rest of the world.
We really need to mobilize all backgrounds in the industry, and it's going to take all types, from engineers, technicians, communication people, economists, anyone. So even if you don't have a 4-year degree, I encourage people to come to the BIC, come to the industry, learn a lot, join us.
We have a responsibility as an industry to make sure that we're looking at the entire ecosystem. So where does everything come from? Where does it go after you process your part, and what industries does it serve? What product does it go into? And then how we look at extending the life of that product.
Simply put, be a scientist, save the world. So we know that energy has been the #1 problem facing humanity in this century. We need to continue in this vision and advocate for cheap, clean energy.
Challenges and next generation is always a good question here at the BIC.
We have an obligation to advance awareness of second life applications of batteries.
In this industry, a lot of the batteries that are done are not done. There are opportunities to remanufacture, to repurpose into low-cost opportunities or next opportunities, and then there is the recycling.
Find a second home for those batteries, whether it be in an energy storage system, whether it be for home or personal use with the proper training.
And I think through LiBridge, this is an opportunity for us to look at how is what we're doing for others, how can we replicate that model throughout the US? How can we work with others to replicate similar models or assistive models for the balance of the globe as well, but with that focus on the US to get out in front of our manufacturing, our innovation, and our entrepreneurship curve for everyone else.
Battery Streak is an advanced battery materials startup offering ultra-fast charging at room temperature and longer cycle life. With our technology, a cell phone and an electric vehicle could charge to 80% in 10 minutes. You can think of electrodes made with our technology as sponges with very small pores, many times smaller than a human hair. These sponges have a very large surface area per unit of volume. We store energy as a surface charge rather than a chemical phase change. Using these sponge-like mesoporous materials, we charge like a capacitor and discharge like a battery, with minimal heat generation in both processes. Our materials are different, but the battery architecture is the same as any traditional lithium-ion battery, so our batteries can be made on industry-standard battery lines and equipment. Battery Streak is currently moving into a larger facility and increasing our material production by a factor of 20, moving from the prototype to the early manufacturing stage. Battery Streak will be providing a demonstration at the Advanced Naval Technology Exercise Coastal Trident 22. And are currently working with the Army and partners on an aqueous electrolyte. We've also received an NSF, SBIR, STTR grant to develop a cobalt-free cathode. Additionally, other downstream commercial end users have expressed substantial interest. There is a weak link in the U.S. supply chain for bringing new battery technology to market, and that is cell manufacturing. We can get 10, 20, or even 50 cells made by a contractor. But if we need to produce hundreds or thousands of cells per month, there are simply no domestic options. Supporting our growth will allow us to hire more chemical engineers, process engineers, and battery cell manufacturing employees, creating high-level American jobs in the energy sector. It will also allow us to create or develop a partnership with a domestic cell manufacturing facility. Battery Streak respectfully asks that you provide grant support to our advanced battery material development and to increase cell manufacturing domestically, allowing the U.S. battery market to outcompete our international competitors. In addition to direct grants, we suggest considering development zones, tax incentives, and assistance streamlining both state and federal permitting and environmental requirements. Please help us be a part of the LiBridge to continue our advanced materials research and development, create new STEM jobs, and develop domestic manufacturing capacity to serve the DoD and commercial downstream markets. Thank you.
Hello everyone, my name is Jun Liu from Han Energy Enterprises. I'll talk about our plan for demonstration of continuous supercritical hydrodermal ALD-coated single crystal NMC and LFP cathode material manufacturing in the United States. Han Energy is one of the largest private energy companies. We have a long history of operation and development in oil, gas, LNG, refining, power, utility, and energy storages. Our venture is Han Energy Enterprises, and we have been developing ALD-coated single crystal NMC and LFP cathode materials. We have two technological pillars. One is continuous supercritical hydrodermal cathode synthesis, and also the coating solutions by using atomic layer deposition. Our technological status and target in 2022 is scale up. So regarding the cathode material synthesis, our target is more than 2 to 3 tons per year scale up. That is our plan with Argonne National Lab under the United States Department of Energy Battery Manufacturing Program. And then our coating scale up target is more than 10 ton per year level. This is our plan for demonstration. This is 4-year demonstration and development plan. The first year and a half from 2023, our plan is to do pilot scale prove out more than 100 ton per year scale. And also we are going to combine our cathode synthesis and ALD coating into one system. And for the other 2 year and a half, we are going to perform the demonstration plant development in the United States. That is more than 1,000 ton per year scale. The picture in the middle is an exemplary picture of demo plant. And the picture on right-hand side is one of our existing refining facility. We are going to utilize our existing infrastructure and experience and knowledge and workforce and experts for developing the demonstration plant. These are the challenges of the United States battery manufacturing, and then our approaches and strategies to resolve these issues. Thank you for listening. If you have any questions, please feel free to contact at this contact information to me. Thank you very much.
Dynamic Battery Corp enables faster charging and higher power lithium batteries using novel manufacturing technology. Current battery manufacturing technology is robust but lacks precision and flexibility. We create microstructure electrodes using digitally controlled tools. Our proprietary technology leverages self-assembly and self-segregation to place binding materials out of the way of the lithium-ion pads. These microstructure electrodes contain scientifically proven secondary pore networks that enhance the lithium-ion mass transport, creating an electrode that is up to 80% faster charging and higher power. The TRL5 honeycomb-shaped microstructure electrode is compatible with most current and future battery chemistries and architectures, including solid-state cells. Our digital technology allows for faster laboratory-to-factory transition, and creates a drop-in solution to current production lines. To fulfill the promise of the electric vehicle industry and enable high-performance aerospace application, innovation in chemistry is not enough. Dyname is developing microstructure electrodes manufacturing technology for better battery cells today. Dyname Battery Corp is growing, and we are looking for financial and commercial partners as well as team members. Dyname is establishing a facility in Maryland where we will expand our technical team in the next 18 months. Help us build a new era of American battery manufacturing. Reach out at info@dyname-battery.com for more information.
At Ateo Systems, we're developing radiation-curable composites to enable rapid, inexpensive, and cleaner electrode manufacturing, thus addressing battery manufacturing here in the US. We've identified that the manufacturing process of the key components, specifically electrode, has remained unchanged since the 1980s. This is bottlenecking efforts to scale and lower costs. We find that the current process is extremely slow, expensive, and toxic, where we take these toxic solvents, mix them with battery powers to make kind of a ink that is then coated onto metal foils to form an electrode. This solvent is removed with expensive, long thermal runners and becomes extremely toxic and has to use an expensive process and energy to remove these solvents. And so that's why here at Tails, we've developed a new solution that uses light. We have proven the elimination of these solvents and this process will enable electrode manufacturing to be 10 times faster, 5 times cheaper, and in fact 12 times cleaner, without compromising performance. And what's really exciting about this technology is that it is chemistry agnostic, enabling its use on any type and size of battery. From developing better batteries for wearables and IoT in a $300 million market, scaling to drones and power tools, and eventually impacting the $50 billion market for grid and mobility. And while we and our company need significant support in developing this technology, we know that the US has to make significant infrastructure and workforce advancements to allow the whole industry to pursue forward. And we see that the US faces many challenges across this whole spectrum of the value chain, from material, electrode manufacturing, and battery assembly, because only 1% of lithium-ion batteries are manufactured domestically here in the US. And we can look to the past for a solution, where in the 1980s, the US faced the same challenges in the semiconductor industry that we face today. It made significant investments in called Semitech that dedicate the investment in building the infrastructure, education for workforce, and advanced materials to keep America ahead across the competition. And we believe in this model because we've already proven it here at the Battery Innovation Center. This is one of 3 facilities in the US, significantly smaller than Semitech, but has allowed our company and a lot of others to move faster, understand their costs, and build robust teams. And we believe this is the model, along with our technology, to really enable battery manufacturing here in the US. Thank you.
Eagle Pitcher Technologies, a superpower in battery technology. Eagle Pitcher is uniquely qualified to provide power. We can connect technology to manufacturing. We understand the full spectrum. We start with chemistries, develop cells, build batteries, and have American manufacturing. With 100 years of battery history, we tackle mission-critical power challenges. Eagle Pitcher supports industries with mission-critical applications. We are a leading supplier of missile batteries. We hold approximately 85% of the U.S. market. As the leading provider of thermal battery systems to the Department of Defense, Eagle Pitcher supplies power for the majority of the U.S. military's missile and precision-guided munition systems. Eagle Pitcher became a battery supplier to the U.S. government in the 1940s when we supplied our first battery for a military Navy application. Our products are used in defense systems such as missiles, torpedoes, and advanced programs, including directed energy weapons, hypersonic systems, and unmanned underwater vehicles. Whatever the requirement, Eagle Pitcher has the solution to power your military application. Eagle Picture's space heritage dates to the earliest days of the U.S. space program, when we powered the first U.S. satellite. Eagle Picture has supplied batteries for more space missions than any other company. Our space batteries have powered launch vehicles, satellites, space research missions, and manned and unmanned missions. Eagle Picture developed and manufactured the first lithium-ion battery ever used in military aviation for the B-2 bomber. Whether it is 2 batteries for a Mars rover or 2 million cells for aviation, Eagle Picture will always rise to meet the individual demands of our customers. Eagle Picture has a long history of battery development for the medical industry. We developed and manufactured the first human implantable lithium-ion battery and the world's smallest implanted battery. The Eagle Picture team is based solely in North America and focuses on the development and manufacturing of power solutions. Eagle Picture's domestic manufacturing footprint provides us the ability to conduct rapid prototyping. We have advanced automation manufacturing facilities and scalable automated production lines. Thank you for joining us. For more information, visit www.eaglepicture.com.
Hi, my name is Eric Roundtree. I'm the head of operations and business development at EC Power. We are the inventors of the thermally modulated lithium-ion cell. This technology was key for the all-climate battery, which was recently featured at scale, powering the public transit system for the 2022 Winter Olympics. It has also been utilized in the development of the Fastline Extreme Fast Charging Battery Series, and is now paving the way for true economy electric vehicle batteries that are safe, affordable, and critically practical, from top to bottom, for the end user, the manufacturer, and the battery designer. Currently, our technology, which is 100% American-owned, is only produced at the prototyping scale within U.S. borders. In the past, we relied on foreign partnerships to achieve our automotive demonstrations and Olympics deployment. Now the opportunity is here to change this. We are well positioned to provide a distinct competitive advantage for the U.S. battery ecosystem. The DOE's planned $7 billion investment has significantly shortened the time required to bring this to fruition. EC Power and our partners will build a production line that produces our proprietary cells and plug-and-play modules under the same roof. The facility will supply modules to targeted traction battery markets already undergoing electrification, and will be a demonstration line to help automotive partners build out new or retool existing battery lines for our technology. In tackling this vision, we realized that we are part of a greater battery manufacturing infrastructure. To be cost competitive at the cell module level, we must be able to domestically acquire the raw materials at cost competitive prices. We must have recycling efforts built out near our plant facilities to drive down the cost and waste of scrap cells. Beyond materials, we must invest in our communities. The skills needed to build out efficient manufacturing lines are already present. But education is required to sharpen those skills around the unique challenges of lithium-ion battery production. In the short term, the few advanced battery companies that exist in the U.S. will need to bear a significant amount of the burden for that training, and will need support in this effort as we scale. In the long term, facilities akin to small, advanced toll manufacturing centers should be built out at numerous universities across the country that can provide training, students, and opportunities for low-cost innovation to the many new startups that we should expect to see in this space. For small businesses, the heart of our country's ingenuity, these manufacturing centers eliminate the capital needs associated with building out full pilot lines, instead allowing them to focus their full attention on their specific area of innovation within the supply chain. With proper allocation of proposed investment by the DOE, the U.S. can do more than just participate in the global battery revolution. We can lead it. The technology needed, ours and others, is already here. It's imperative that it stays here and that it scales here. EC Power is looking forward to playing our role in that future.
All right, I think we are making great progress so far, and we have completed all the video presentations by the companies, and we are almost on time. I want to thank all the companies who participated, also all the audience for the hard work and the patience for the last 2 days. And we are making it to the end, I think. With that, I would like to give back the time to Venkat.
Thank you so much, Jun. Deeply appreciated. And thank you for all the people that presented videos today. We were having an email chat among the moderators, and I was sort of commenting that, or somebody, actually Esther was commenting that a lot of startup companies and a lot of new technologies coming up, and it'll be great to see how you guys can sort of evolve and get to the stage where you're making gigafactories. We're now going to move to a very important session, a session that is going to focus on the questions that have come up in the chat window, things like workforce. What are we going to do about it? Especially because we are at a time when we have to transition the workforce from an ICE workforce to a workforce that is going to be on electric vehicles. That's the first part of what we're going to think about. The second one is we have to start thinking deeply about environmental justice and equity. Right. Remember now that as we start to go into this revolution, there's going to be a lot of displacements of jobs, but also displacements of people who take advantage of these jobs. How are we going to bring everybody along and we go to the new economy is something we have to think about very, very deeply. So this is a topic that we're going to explore in the next session. As you guys have probably heard in the morning's presentation from Dave Howell and also from yesterday's presentations, if you were there, this is going to be an important part of the thinking as we start to evolve in this infrastructure bill. So we're going to spend some time talking about that aspect. But before we go there, I want to use the chat window, the window that you guys have been doing. We will not go to polling now, we'll be in the chat window. And I want to ask you guys two quick questions. The first question I want you to sort of type in the chat window is, how well do you have environmental justice baked into your production plans? Is this something that you already have plans for, where you know what you're doing? Or is it something that you're struggling with? And I ask this question because there are people from the Department of Energy who are actually there who can help you with understanding how to go about coming up with ideas that could help you with the environmental justice component. So I want you to use the chat window. If you can let us know what kind of plans, what is it that you're doing today? Is it well established? Do you feel like it needs a lot of work? Let us know, and that'll be extremely helpful for us as we start to think about how to help you as we go to the future. So let's take a minute or so just to think a little bit about whether people want to respond. And I don't see many responses at this moment. So again, use the chat window. You will see it. Make sure you chat to everybody. And if you can let us know what you think your plans are. Do you have a proper plan? Do you feel like this is something that is a work in progress? It'll be great if you can hear from all of you. I'm going to pause for a second and see if people want to start chiming in. And again, you may want to be succinct. A few words would be all that you need to use, I think. Thank you. I see one response coming in. That's, it's good to know. It says work in progress. I suspect that a lot of people are going to be thinking that. Again, the more you let us know, it's helpful for us because it'll help us understand how we can help you. So if you already have plans, that's good to know. And if you are still, if it's like Eric and Ellie said, I'm sorry, the work in progress, we would appreciate knowing about it. Thank you. I see a little bit more information there. I see another request for help from DOE. That's great. So as the chat is coming in, the second question that I want you guys to kind of think about and maybe use the chat window to talk about a little bit more is, incorporating the community's voice is going to be very important. We've seen challenges when we don't do that, and we start to create plans without thinking deeply about where we're going to locate the production. So I would like you to think about that, and if you can provide your thoughts on how you're going about incorporating the community's voice in your plans as you go up from your, whatever technology level you're in to those gigafactories that we're going to build out, that will be appreciated. So please let us know. With that, what I'm going to do is I'm going to actually invite a very important person to come and join us. This is Michael Berube, who's the Deputy Assistant Secretary for Sustainable Transportation in the Office of Energy Efficiency and Renewable Energy. Michael actually gave us one of our opening presentations yesterday. For those of you who missed that, he gave us a beautiful picture of painting a picture on where the administration is going. Today, he's going to be playing a slightly different role. Michael has also been thinking deeply about the questions of equity and environmental justice and workforce and permitting. So I want to invite him. And before I do that, I want to sort of tell you that Michael's portfolio actually covers quite a bit. It's certainly sustainable transportation, including vehicles, hydrogen and fuel cells, and bioenergy. So kind of a broad portfolio. And Michael has many years, 25 years of experience from the automotive industry, looked at various components like environmental compliance, energy and safety policy, product development, and marketing. And over the last many number of years, Michael has been a fantastic friend of the National Labs, leveraging the expertise we bring to the table. So without further ado, I want to make sure that Michael is on. Michael?
Thank you very much, Venkat, and really pleased to be able to join the team here today. I'm sure that you guys had a great day of sessions. I want to introduce the next two speakers, and then we'll come back and have a little bit of a discussion. Betony Jones and then Shalanda Baker are both going to speak. I'm going to introduce both right now. We're going to run, they both had to do by video. Betony is Senior Advisor for Workforce for our group here at EERE. And Shalanda Baker is the Senior Advisor to the Secretary for Environmental Justice and Diversity. I want to really emphasize that the message that both of them have is critically important, from the Secretary to my boss, Kelly Speaks Bachman, down to me. And I think the key message that I'd like to share, and I talked a little bit about this yesterday at the introduction, was that the vision we all have to achieve decarbonization across the grid and across transportation will not happen if we do not find a way to make sure that all Americans see themselves in that transition and see their role in it and see how they can play as part of that. So that speaks to the workers, the people who, quite honestly, as we're in a transition, that will be transitioning jobs from whether it be energy or automotive and want a new place in the clean energy economy around batteries, for example. And if we don't have the equity and justice so that all Americans really see themselves in that the changes are relevant to them, that those burdens, that those communities that have been overburdened over time see now that they are basically really being listened to and really have equity in the changes that are happening. So with that, let me first, we'll introduce Betony, and then we'll run right to Shalanda, then we'll come back for a discussion.
Hi, I'm Betony Jones. I'm a Senior Advisor for Jobs and Workforce in the Office of Energy Efficiency and Renewable Energy. I'm going to spend a few minutes talking about our workforce development efforts and the EV transition. So first, we know that there are some challenges. The auto industry, which will be affected by this transition, is a key employer. We know that EVs require about 10% less production labor than internal combustion engine vehicles, so that poses a challenge in terms of job loss. We also know that the battery sector jobs are primarily non-union and pay less than ICE jobs, and so there's a problem with job quality. Policy support can minimize worker dislocation, job loss, wage loss, and the decline of unions, but it's going to take some intention. Policy really needs to look at how to increase domestic content, develop the US supply chain, ensure continued innovation and competitiveness, improve job quality in order to attract and retain the qualified workers that we're going to need, mitigate local economic shocks, and spur consumer demand. So there are some opportunities, but there are also some real challenges. Among these challenges are the geographic challenges. This map shows the light vehicle production supply chain. The black dots show the assembly plants. The orange dots show the supplier plants. This is really concentrated in certain geographies. And if ICE jobs are not replaced locally, some communities will be exceptionally hard hit. Even if EV and battery jobs do replace ICE jobs, there could still be reduced wages and job loss. So we absolutely have to get this transition right from the worker perspective and the political economy perspective and the geographic perspective. What does this mean in terms of our thinking around workforce development? Well, we know that a qualified and available workforce is going to be really key to building out the lithium battery supply chain in the US. But we also know that when workforce development efforts focus solely on training, we can't solve the problem. Training alone is a supply side strategy that can produce a lot of workers into the labor market, but if there aren't good quality jobs for them to go into, we're going to have a problem attracting and retaining the workers that we need. So to quote an article from December from the Aspen Institute, workforce development should focus more on fixing work, not just the workers. Job quality is key to attracting and retaining qualified workers. And job quality, we have a problem here because in announced battery plants, the job quality is worse than in powertrain plants. Wages average $19.50 an hour, and almost all, with one exception, are non-union. There are also significant public costs of both job loss and poor job quality. The estimated social cost of closing a plant is $150,000 to $350,000 per worker. There's also public costs of low wages. A study from UC Berkeley a few years ago showed that production line workers generally, not only for battery manufacturing or in advanced manufacturing, but generally enroll in federal safety net programs at the same rate as workers in the fast food industry. So these manufacturing jobs are not what they used to be, despite massive improvements in worker productivity. Fixing the jobs, fixing the quality of jobs is going to be key to our workforce efforts. So how does this influence how we're thinking about our workforce priorities? One, like I've said, we need to grow jobs through efforts that support the development of domestic supply chains, particularly in energy and automotive communities that face transition risks. And we need to improve the quality of jobs. And this includes supporting efforts to increase unionization in the battery supply chain and EV supply chain and other clean energy supply chains. When we do think about the workforce education and training side of it, we really need to center both worker and employer needs and make sure that both workers and employers are well represented in the development of training standards and in the development of training programs. A few ways to do that are to support labor management training partnerships. These can focus on both worker and workplace health and safety, on the training that can support workers advance in their careers, not just get that first job, and that look for other opportunities to advance the firm competitiveness through workforce development, something that both the employers and the workers would benefit from. We're also looking at how to coordinate with the Department of Labor and expand registered apprenticeships and manufacturing apprenticeships. Registered apprenticeships are earn as you learn models of training that result in national industry recognized credentials. These work really well in the construction sector. And there's a lot of other industries that registered apprenticeship would be a good model for. Sometimes in construction, we see this a lot. These registered apprenticeships are jointly funded by both labor unions and employers because both sides benefit from that investment in training. That's what we need to see more of in the manufacturing space. Additionally, the last thing that's going to work is to have dozens or scores of different training programs across the country leading to different certifications or different credentials. Workers don't know what to make of that. Employers don't know what to make of that. And that is not the path to support improved job quality or targeted investments in the communities that need them. So one of the things that we think is really important is to engage industry leaders and labor in the development of national training standards that lead to industry recognized credentials. So workers know where to invest in their skill development and education that is going to lead to a job and upward mobility within that job and within that career. And that employers will also know what does the particular credential signal in terms of worker competencies. So that standardization is really, really essential. In closing, I just want to say that this is a challenge that we are up for. This is possible. It's really exciting to think about how to build a new industry right from the get-go, an industry that will support good, high road, good paying union jobs and increase US competitiveness. Thank you very much.
Good afternoon. I'm Shalanda Baker, and I'm so proud to serve as the nation's first ever Deputy Director for Energy Justice in the Office of Economic Impact and Diversity. I want to thank Argonne Lab for hosting this two-day convening where we are all focused on bridging the gaps to advance our nation's battery manufacturing, recycling, and supply chain. Argonne and DOE's other 16 national laboratories lead the nation in advancing the frontiers of scientific knowledge and innovation, keeping our nation secure, and fueling our clean energy economy. And the simple truth is, diversity, equity, inclusion, and accessibility are essential to achieving these goals. The innovation at the heart of the laboratory's success benefits from diverse talent and inclusive perspectives. We can and should work together to make sure we are maximizing diversity in talent and inclusivity in perspective. It's my office's mandate to ensure that people of color are afforded opportunities to participate fully in our nation's energy programs. And as part of that, we must all think creatively and critically about how the battery manufacturing and recycling industry can be more inclusive as we expand and electrify our transportation infrastructure and as we transform ourselves into a clean energy economy. And so in alignment with these goals, we're working hard daily to expand the participation of minority-owned businesses in DOE programs and to increase access to new opportunities. So we see the bipartisan infrastructure law, or the bill, as an important vehicle to do this. The bill is a long overdue investment in our nation's infrastructure, workers, families, and competitiveness. The battery provisions we are discussing today represent over $6 billion, that's billion with a B, dollars, to advance the science and innovation required to meet the demand and to drive our nation forward. It's our belief that the bill provisions are incredibly important in not only addressing our infrastructure needs, but also advancing equity. These provisions will be the vehicle to provide jobs in BIPOC and low-income communities who have unfortunately disproportionately borne the environmental burdens of the energy system while reaping so very few of its economic benefits. And we also see opportunities for grants for minority-owned businesses and nonprofits. We encourage the creation and prioritization of business models that are people and community centered. So all of you present today represent the innovation and ingenuity we need to make this possible. I want to impress upon you that your work must be inclusive of minority serving institutions, community colleges, technical training programs, and the workers who will be local to and will most likely be impacted by this work. We encourage you to push the levers of creativity to conduct this work in a manner that is respectful of our environment, our resources, and our people. Environmental justice principle must also be core to your projects. You must acknowledge the potential environmental harms associated with the lithium and cobalt extraction process, as well as the excessive use of water that impacts the communities living near these mines who may be negatively harmed with the loss of access to clean water, or who may be dependent on land and waterways for farming and fishing. So local consultation and meaningful engagement must be a critical part. Both of these things must be critical within all of our projects to mitigate further harm to these communities who are already burdened by the climate crisis and who have experienced generational harms within their environments. So if you're not sure how to lead this important work with these ideals of equity in mind, our office, the Office of Economic Impact and Diversity, is a place for you to receive guidance and resources. And finally, We must work hard to maximize the benefits of every single dollar spent through this battery manufacturing and recycling program to ensure that 40% of the overall benefits of these investments flow to frontline, underserved, and overburdened communities. This is the essence of the historic Justice 40 initiative, which holds the promise of transforming, yes, transforming communities. And so we, all of us, have the responsibility to ensure that the communities on the front lines of this climate crisis receive the benefits of the transition. This is the promise of an equitable clean energy transition. This is your work today. This is our work together. And this is the promise of the Biden-Harris administration. And I should also say that this is the moment that we've been waiting for. This is the moment we've also been training for and been dreaming of. And I am so honored to work with committed and incredibly smart colleagues across the national labs, across the Department of Energy, to help us transform the nation and our world. So this is our moment, and you have your work cut out for you. I look forward to working with you as we transform our nation's energy system into one that is more clean, that is equitable, and that is just. Enjoy this conference. Thank you.
I'm going to now invite back Michael, along with our 4 moderators for the day today, my friends and colleagues from the other national labs, Jun, Esther, Eric, Ilias, if you can turn on your camera and come on, that'll be fantastic. And I'm going to first, before we jump into some sort of discussion, which would be really fantastic, I want Michael, maybe if you want to reflect a little bit on what we heard and sort of inform the community as to the importance of what we're hearing, that'll be great.
Yeah, let me do that. And first say hello. It's great to see all great colleagues here from the battery team and the national labs on. I think there's a few specific notes that I took from the comments we just heard that I'd like to maybe really emphasize. I think from the comments Betony made on workforce, I'd like, everyone who's listening, many of you maybe are thinking about putting in applications in these under this notice of intent we've issued. Recognize that we are taking very seriously the need to focus the location of these new cell plants, especially in those communities where there are lost jobs in the energy or the automotive side, people that are involved in the fossil fuel industry, whether it's making internal combustion engine or coal. So we are going to be giving serious consideration and to that location because it's really important for that workforce. The second thing, we are committed to workforce training. As Betony said, there'll be a significant announcement tomorrow by the secretary on workforce training that you'll hear. And we are going to, I really want to partner with those of you in industry as well as organized labor and training providers. I think from Shalanda's comments, I guess I would also like to say, for those of you that have applied recently for funding opportunities from the Department of Energy, you've seen that we are asking everyone to put together a diversity, equity, and inclusion plan. We're asking everyone to have meaningful and serious consultation with people at the local level, that in the communities where you're looking to put manufacturing, in the communities where the projects that we're funding will be impacted. Shalanda offered her office is there to help. I will say, working in areas of diversity and equity, these are not areas that probably many of us are used to working with on a day-to-day basis. While it may be a priority and something we believe in, we're not experts. And that maybe creates a little bit of uncomfortness. We say, what does that mean? What is it you really want me to do? So I'd encourage all of you to say, because maybe it's an area that we haven't focused on enough, and it is something we have not focused on enough in the past, doesn't mean that, and therefore we're a little uncomfortable with it, doesn't mean we can't dive in. And Shalanda's team is actively there, willing to help and work with us to figure out how do we do that. And I will tell you from the work we've been doing the last year that meaningful consultation with the local communities is the critical piece to understand how they are being impacted, how they have been impacted, and what through this transformational investment we have, we can do to help move that forward and really change some of that. So really, Venkat, those are my I guess thoughts and observations, but would love to hear from the panel of what they've heard through the day and from other companies and presentations.
That'll be fantastic. Yeah, we should do that. I want to start off with the education piece and the workforce piece. We heard from actually we had a poll everywhere question today, and people said a majority of the interest appears to be in the process engineering world, but also some STEM, but also the technician level, right? We heard about the sort of the mix. And we have an interesting group of people from the national labs. There are two people who have joined appointments with the universities. That would be Esther and Jun. And we have Ilias, who obviously Oak Ridge is thinking a lot about battery manufacturing, and Eric, who's thinking about the testing and the characterization piece, and how do you think about those aspects? So it'd be good to kind of get some thoughts from you guys. What did you hear? What are your thoughts on which way to take it? Maybe we'll start with Esther and then sort of move to the others one by one.
Thanks so much, Venkat, and Michael, thank you for your comments. These 2 days have just been really, well, it sounds like a joke, but energizing, really exciting time. I think workforce development is really an interesting thing. And, I myself have a background in manufacturing. And in the manufacturing jobs where I was, there was a lot of demand for process engineers in particular. And at least at the company where I work, these were positions dominated by bachelor's and master's degree engineers. I would say that the production workers themselves didn't always have bachelor's degrees, but then the production supervisors did. So I think it is a move towards jobs at every level. And I think it's a good time. I think one of the things that occurs to me is that still, I know from my own experience, even students who, at undergraduate or graduate levels who are interested in this broader space, still have a hard time knowing where to look and who to contact. So maybe some way to better, link the prospective interested applicants with opportunities might be great.
Fantastic thought, Esther. I see Jun's hand up. Go ahead, Jun.
Thank you very much. I just want to follow up on Esther's comment on the workforce and education, because I'm also in a way an educator now. So I am located in Seattle. The University of Washington is located in Seattle. The workforce training in engineering is really tough and desperate right now, from my perspective. In the Seattle area, in the past, people talk about science, technology hard, engineering hard. People go to lawyers and doctors, things like that. The lawyers and doctors for the kids in Seattle area are the past already. People can come do 2-year program, computer science engineering, community college, or University of Washington, or Seattle University. They get very good jobs with Microsoft, Amazon, Google, things like that, make tons of money. When they compare with engineering, particularly the hardcore science engineering, it's so difficult, so much work for 4 years or even longer. And then you probably end up making 1/3 as much money as computer science and other things, or just simply people who can write codes, right? So it's really desperate. I think we really need to work with community colleges, universities. Esther is here, that we need to think very hard how to redefine our science and technology programs, make it flexible, make it accessible to all different kinds of people, make it accessible to underrepresented groups, and invite industry to come in so that they can see. I think the kids, they need to be excited about it. They need to see that they make some good effort and they get paid back. Unless we do that, I don't know who, it's so hard right now.
Yeah, it's a very valid point, Jun. I want to turn to the other two because you guys, you guys heard the comments today about how National Lab should be helping. What are you seeing? What are you guys thinking of when it comes to workforce? And maybe we'll start with Ilias, then go to Eric next. Ilias?
Sure. Thank you very much, Venkat. And I would like just to start by saying, by all measures, we don't want to be in a situation where workforce development would be rate limiting for those who are in the science and physics education side of what we're doing. But the one actually observation that or notes that I learned from yesterday and today, actually, we don't want this to be a hope, as Mike Berube mentioned. We need to move to the action. And I heard from a great word actually from Betony, which is about intention, being intentional and really looking at this matter very carefully. And we understand there is no one solution to it. James mentioned that manufacturing competition could turn actually out to be a workforce training competition. And that's valid point because it looks like other comments mentioned that it's just difficult to be profitable in the US, having training programs across the supply chain. But on the solution side, Venkat, I believe, the infrastructure that exists in the national lab, it's not going to be the solution, but part of the solution. We have those infrastructure, we have those battery manufacturing facilities, whether at Argonne or Oak Ridge or PNNL or other places in the national lab. And those could at least provide some probably pathways for a short-term solution to educate and train at least, those who could quickly access the workforce area immediately. So those are my general comments, Venkat, and I'll let you take it from there.
Thank you, Ilias. I think it's going to take a lot of experiments going forward. Eric, your thoughts?
Yeah, so on kind of our view on the national lab side, a lot of what we see is, it came out in some of the talks today and yesterday as well, in terms of kind of an all of the above is needed, anywhere from, high school all the way through PhD. I know one of the gaps that we see, and that I know a few others have seen as well, is that especially at the bachelor's and the master's level, like Esther was commenting on, is we really kind of see a lot of that, of someone ready to step immediately into a battery job without a lot of additional training on our part is something that comes up very, very often. You get really good students coming out in electrical or mechanical engineering, but you have to teach them the battery side of it, or the battery system side especially. So that's one of the areas that we see a lot of. And I think a lot of that goes back to the conversation of, talking to the local universities, talking to community colleges and saying, how do we even talk with the lab, their industry, and say, what are the real skill sets that you need? Because I think that's a conversation that's pretty easy to actually start moving forward. So
this is fantastic. I'm seeing some good comments coming out in chat also. I know we are running up on time, but I want to explore one quick thing. You guys represent 4 different parts of the country, right? Northeast, Southeast. And I want to ask you, looking at, for example, Illinois, there's a big question we're asking about how do we transition coal country? And that's hard, to Michael, the point that you made a little while ago. We don't know how to do these things very easily. I wanted to ask and see, what are you guys seeing? And maybe we'll start with Eric this time, just because, and then in the end, Michael, I would love for you to sort of provide some perspective from your stage. But are you seeing stuff in your state, Eric?
So yes, we're seeing more on the material side, right? So where do you get cobalt? Where do you think about processing? How do you think about those types of jobs? If you look regionally, though, just south of us in Utah, I know there were a couple presentations today coming from Utah on the manufacturing side, pack integration. If I look just to the east of us, Wyoming's facing very similar issues as well. If you look at coal or other fossil generation, there's potential hits there. So we're hearing a lot of conversations regionally, really, of how you think of not just the immediate of producing the materials you need to go into batteries, but also how do you co-locate and think about the full supply chain, really, and supply chain logistics of taking stuff from one location to make sure you can get it where you can actually get it into a pack and then a vehicle.
Thank you, Eric. In the interest of time, I want to see if somebody should raise their hand and see if they want to talk about it. I was going to ask you, Esther, about New York, which obviously has a long history of thinking about this question.
Yeah, let me talk about New York. And then I have a thought, Ashley. Betony's presentation really is, I think, making all of us think. New York is really trying to be very aggressive, not only in clean energy, but in trying to stand up significant battery manufacturing. Of course, New York is also the home of NY Best, which is a very dynamic trade organization involving, hundreds of partners, many of whom are industrial. So my comment about the future is that I really very firmly believe that this is an opportunity we must seize. It is clear the world is going in this direction. So while we can, and rightly so, think about the jobs that are being lost, but here is an opportunity to replace them with something important that is going to be a worldwide competition. And so if we cede this opportunity, then it's difficult to see what exactly will replace this opportunity. So, maybe I'm viewing this as glass half full, but I really do think we're on the cusp of doing something incredibly important that is can position the U.S. in a very strong way and solidify a lot of the economic and manufacturing base.
Profound words. And Jun, yeah, go ahead, Jun. I mean, it's a very quick comment.
Yeah, very quick. So if we look at the distribution of the natural resources in terms of renewable energy, electricity, water, those kind of things, it's kind of very interesting. Most of those actually are distributed more in the undeveloped areas, but the developed area mostly concentrated in a few big cities and coastal regions. So I think we do have an opportunity here to strategically think about this, either in terms of developing new manufacturer supply capabilities or demonstration projects. I think we can strategically rethink the whole thing, where we want to do this in the country.
Thank you, Jun. I'm going to give it back to Michael and see if you want to have final thoughts on this session before we go to the final one.
For Venkat, I want to say thank you to you for hosting some great comments in there. I think people are looking for a second job for you as an MC. You've done a great job the last 2 days. So thank you, and to the others here from the lab. On this topic, I think that all the comments good. Eric, you comment about regional and thinking about parts of the country you're in particular. I was recently with a senior state official in one of those states, and he was listening to us talk about the vision of batteries and where we're going with electrification. He's like, man, I got to tell you, people around my part of the world aren't seeing that. Now they are seeing these new commercials on the Super Bowl and Olympics, and they're wondering what's going on because they can't imagine EVs are going to be given the geography, given the rural environment, given all of that. And that's part of what we're talking about, right? All Americans seeing themselves in this transition. So I think all of us, while we are probably many of us in this call, we're technologists, we're engineers, we're scientists, we do have to be thinking about the bigger picture here. We have to be thinking about the human side picture, the societal aspect, because the change we are trying to drive is nothing short of impacting every single person, how they drive, every single business, how they transport their goods, the types of vehicles they get, the fuel they use. It will literally impact every single person if we're successful. And so we got to think about that in that context, I think, when we think about diversity, equity, inclusion, workforce. So I just appreciate everyone really taking that journey with us, if you will, and really trying to work through those issues. Venkat, I'll hand it back to you to close.
Thank you, Michael, and thank you to my National Lab friends. So I'm going to, Michael, if you can hang on, I'm going to get Dave Howell to come back in. I think yesterday he was looking for you. And thank you to Eric, Esther, Jun, Ilias. The day was fantastic because you guys brought it home. So Dave, if you could jump on for the closing.
Hey, thank you, Venkat. And I realize it's been a long day, a long 2 days, but definitely a very beneficial workshop. So I'd like to, first express the department's appreciation for the time and effort that you've put into developing your videos, for participating in the polling Q&As and the chat, the information and the insights from today's workshop and yesterday's workshop will provide important input to our efforts to build out this phase of the BIL battery supply chain efforts. As I mentioned earlier today and yesterday, our plan is to release our phase 1 funding opportunities later this spring. And once released, be sure to, my advice is to be sure to read the entire document and feel free to submit any questions to our frequently asked questions link that will be in the document. So that's the phase 1 effort. We did keep some powder dry. The notice of intent shows about $2.9 billion allocated, and we'll see if it's a little more than that or a little less. We'll see what we have, once we get the applications in and go through the evaluation process and selection process. But, in the out years, this is a 5-year effort, funding effort. So in the out years, we do expect to have additional FOAs to fill in the gaps in those high priority areas that of commercialized technologies or even next generation battery technologies. And particularly, hopefully we'll get some successful scale up demonstrations in this first phase of conventional and non-conventional technologies and processes that we can have some funds to support scale up of those in the out years and address emerging industry needs as well. So, so just wanted to connect you in to make sure that this is a long-term effort, not just 1 day or 1 year. This is a 5+ year effort to build out the battery supply chain for the United States. Meanwhile, you can continue to submit your questions through the frequently asked question link attached to the notice of intent that were released in February as well. So, continue to provide your questions and cues. We'll answer the ones we can. Some of those will depend on as we finalize the FOA. You'll basically need to read what's in the FOA document, but we do take those questions and consider them and determine if we can actually provide the answer now, or you'll have to wait till the FOA before we can provide guidance. So with that, I'd like to thank our facilitators these past 2 days, Noel and Tony and Eric, Ilias, Esther, Jun, all key leaders in our battery innovation activities at our national laboratories. So thank you all. Your leadership and support of our efforts is always greatly appreciated. And one last thing is, again, hats off to the LiveBridge Alliance and the team at Argonne, Venkat, Holly, Jonathan, Betony, Lynn, Kristen. I'm sure I've missed some, but you guys have done great. This workshop would not have been possible without your leadership and concentrated efforts to turn all of these things around. So very, very well done, and hats off to you. So now, let's get busy and let's get started. And so
Dave, quick thing, Michael is also online. I don't know if you want to add anything. It's hard to
Michael,
I just want to give thanks, Dave, to you and your team for the leadership here. Let me thank you personally for all the work you've done, helpful, not just this effort together, but in some ways, the last 2-3 years, I feel, have really been us setting up for this transition, this pivot point for this large scale industrialization. So you and your team obviously have done a great job in getting us to this point. And we have a lot of confidence will shepherd us through this process the next year as we really try to grow the domestic industry.
Thank you, Michael. And it's been great. Always a pleasure to work with you, Michael. So thank you. It's been a team effort all the way. So Venkat, back to you with that.
With that, thank you, folks, both Michael and Dave. We appreciate it. And thank you all for participating and folks who stayed on till, I guess, 6 or 7 East Coast time. So with that, the meeting comes to a close. Thank you all. And we look forward to putting all the proceedings online. So stay tuned. You'll get an email on that when that happens. So thank you all. Have a great rest of the day and week.